Good morning. Good morning and welcome to the Naventus Renewables Summit here at Grand Hotel in Stockholm. Wonderful to see you here in the audience and welcome to all of you following us online. This event is hosted by Deloitte, Zettervalls, Nordnet and Nasdaq and Naventus of course. And my name is Katarina Rolfsdotter Jansson. I will be hosting this event. I am a moderator, program host, keynote speaker, and I also work as a chair of the independent think tank Global Utmaning, and I focus primarily on sustainability. And today is an excellent opportunity to listen to experts and companies that work within the renewables sector. And I must say, in the light of the latest IPCC report, and of course the Russian invasion of Ukraine, it has never been more urgent to invest in renewables, right? So it's now my pleasure to introduce the second speaker, because the first speaker is actually stuck in traffic, so we shifted the program around a bit. So it's my pleasure to introduce SmartWires Technology, Peter Wells. And SmartWires focuses on developing technologies that deliver greater grid efficiencies and, well, in order to facilitate a greener planet. So a warm welcome to you, Peter. Round of applause.
Thank you. Well, good morning. It's a pleasure to be here. Well, I was introduced already, but yeah, my name is Peter Wells. I'm the CEO of SmartWires. I actually have about 30 years of industry experience in energy. I did a decade in wind energy, and about a year and a half ago, realizing that there was something not quite right with how wind was getting onto the grid, I started to get a little bit more interested in what was happening with the grid and why that was, in fact, a bottleneck and perhaps a problem to the issues we need to solve. So I moved into the company called SmartWires. Let's take a step back and think about the grid for a second. I think it's fair to say that it's probably one of the greatest inventions of the last century. But I think the thing that most people don't realize or think about is it actually has to be the greatest tech story of the next century too, and I'll give you a sense on why that's the case. As Katarina mentioned, we're all about focusing on modernizing the grid, and that means digitalizing the grid, and I'll explain a little bit more about why that's so important. So, if you think about energy transition, it's a pretty broad paradigm, but at one end of the scale, you've got huge scale adoption of renewable energy. This means phasing out coal and nuclear and other plants. Physically where they are, the generation is moving to new locations, much more distributed. This creates new challenges for the grid. It wasn't wired and set up for this paradigm. In addition, on the other end of the scale, when you think about on the demand side, you've got electrification, batteries, distributed generation, solar, etc. Incredibly complicated new situation for the grid. It was not set up for this in mind. And really, if you look at the technologies that are out there today, you're dealing often with 30, 40, 50-year-old legacy technologies. They can't adopt and deal with this new situation. We know as well that investment in the grid needs to double from 30 billion to 60 billion euros a year just in Europe. And I'll explain again why that's the case. So if I put this sort of changing paradigm of energy transition at the top of the page here, on one side of the page you've got renewable energy adoption. If you saw the recent IEA report, it needs to go up by 4x. We're not even close. So if you think about net zero goals, we're not even close to what we need to be doing. At the other end of the scale, e-mobility, electrification, meaning using greener energy, industrial process and heating, building heating and cooling. All of these different things have to happen, cannot happen unless the grid enables it. So the grid is the nexus of the energy transition. So it must connect these new technologies on the generation side. And I would argue it must also enable much, much more innovation on the demand side as well. So it's right in the middle. It comes with a challenge. And the challenges I map here for you, it's a lot more complex, to be honest with you, than this. But if we talk about congestion issues, large interconnect queues, in the US alone, something like 3 to 7 years is the average time to get a new renewable project onto the grid. So if you want the scale of adoption and the pace of adoption, the grid has to become something different. Stability, strength, resilience, harmonics, the ability to plan and forecast, this new now two-way flow of information and energy, fluctuations during the day, big load management challenges, especially on distribution, and the ability to balance demand and supply. are all new challenges for the grid and the grid operators. So how can we solve those? Often referred to as a family of grid-enhancing technologies, and you'll see there's plenty of reports out in Europe and across the US on these areas. And they're typically talking about modular power flow control, they're talking about dynamic line rating, data science, grid topology, really understanding what the asset looks like today and how to adapt to modernize that asset to give real-time, I would say, intelligence and real-time control. So we put it really in our world, we put it into these three buckets of what we're trying to do. We're trying to look at applications of the technology to solve these problems, very specific. We're then realizing that as we distribute more of the technology, there's the ability to layer services on top of that. And ultimately, at the end of the day, the grid becoming a digital platform. And that's where we play as a company, right in that middle, the bottom zone there, trying to make sure the grid can become this digital platform. As a company based in the US, listed here on the on Nasdaq First North in Stockholm, we have a global presence. We've got offices across Europe. We have offices in Australia and also South America and Colombia. We're about 165 people right now. It's gone up almost by, I would say, 5 or so a week at the moment, so we're in a pretty rapid phase of growth. We also have a couple of key partners. Our manufacturing is done by contract and outsourced to a company called Jabil in Florida. Strong patent portfolio, pretty long history actually. We've been around for 10 years developing and refining this technology. Big pipeline on sales, actually closer to 6 billion now. We've got 60 million in backlog for this year already, and we're targeting 65 to 70 million of revenue this year. So what do we offer? I mentioned a couple of things, but let me be more specific for you. So we do two things really. One is on the analytical side, we do very complex, we're using advanced software, we do very complex modeling, and basically we're looking at the ability for the grid to adopt new technologies, take on new generation, new load, solve problems on the grid, whether that's congestion or strength or resilience. And we've worked with utilities across the world on these studies. Obviously, no surprise, many of those studies lead to the application of the smart valve. And that's the core technology you see in the picture on the right here. Give you a sense of scale, one of these units would be about 5 meters long, 2 meters by 2 meters. This is a transformerless, so it's pretty radical. If you look at the grid today and the technologies, lots of steel, lots of copper, magnetic and mechanical switching devices, none of that is in a smart valve. It's all power electronics. And we're using basically this more advanced technology to inject voltage onto the line. And when we inject voltage onto the line, we can change the impedance, meaning the resistance, and we can change the power flow. And I'll give you a picture in a second of a model, simplified of what that looks like. But this is, just to be clear, this is quite radical for the grid, this technology. Something that is modular, flexible, scalable, and controllable. So we can put these groups of modules, they're typically going to go in for 25 to 40 years of life, but we can scale up and down as the grid needs change, and we can move them. You just simply don't see anything like that on the grid today, not even close. So, taking the power and flexibility of silicon software to move faster and provide better solutions. And the key, I think, as well, I often talk about this with customers, is future-proofing. So we don't know, maybe some of you do, but I don't. If you go 5 years out, maybe we have a sense for what the energy transition looks like. 10 years? 15 years? 20 years? I don't think so. This technology is great for that because of that adaptability and the scalability and the modularity. So the smart valve itself, strong patent portfolio. What's unique about it? I've touched on some of these things already. So it's modular. We know we use these silicon-based converters. We have really advanced diagnostics and analytical capability sets, very unique communication capabilities and controls. We can do things for the system operator. If you think about the ability to turn loads up and down, really scaling and moving in small steps, can't be done today, and you can do this with this device. So we can solve problems on the grid, but we can also give this ability to optimize power flow across existing assets, not against new investment in the grid, to be clear. That's important too. But this technology can also help get better utilization of new investments. The patent portfolio, most of it's been registered in the US, but 35% or so worldwide. We're really focusing on the core technology itself when we do our patents, But we've also spent a lot of time thinking about these other attributes I mentioned, the modularity, the scalability, and things like this, and we put patents around those. Over 100, 140 or so that are either filed or in drafting as well, so this patent portfolio continues to move up. When I joined about a year ago, it was around about 45 or so. Interestingly, when you look at patents, and it's a key thing to understand, prior art is a big deal. There were the patents like this in this area before. With our technology, there are none. So there's no prior art. This means that we have very unique technology. It also means, significantly, if other companies move into our space, we will have a much earlier priority date on any considerations about patent infringement. So it puts us in a strong position. So I mentioned about trying to give you a sense of how this works. And I'm not the brains, the engineer behind this, so I always tell people this is my street story for you. So I'll explain what's going on. So the picture on the left, this is not uncommon. So as you bring more renewable energy generation onto the grid, what's happening is that that power flow will always go to the line with the least resistance. That's just basic physics. But when that line reaches capacity or its specification limit, it can't take any more power. So when you want to add more renewable, or even if that renewable energy is available and you've reached that maximum point, you have to curtail those assets or turn them down. When you drive around Europe, if you see wind farms that aren't moving, it's not because they're not working. Typically, that's because the operator cannot take that power, and they've asked them to curtail or shut down the generation. You, as a consumer, still need your electricity. Where is that coming from now? It's coming from a different place on the grid, and often it's coming from coal or gas or nuclear. And often that comes at a price premium. So you pay it once in your bill, and secondarily, you pay for it with a Climeon. So as a consumer, you should be, in my opinion, hopping mad about this. So we have to solve it. So there are ways you can do it. As a utility, I could decide to add a new line. That would bring more capacity. It doesn't change the efficiency of how the grid is working, but I can add a new line. I could reconductor some of these lines here. That will help too. That will add capacity. How many years for that? Any guesses? 5 years, 10 years? Get the permits, do the work, and now it's there. It's fixed. It's rigid. It can't be adapted or really flexed in any way whatsoever. And you can put transformers and other things there, but again, they're 3-4 years to design and implement, and they're quite rigid in their deployment, meaning they're not flexible for future change. When we put the smart valves on the lines, we're not adding lines, we're not modernizing those lines, we're simply adding the smart valves. We're able to inject voltage. Basically, we do it at a different quadrature to the AC signal. When we do that, we're changing the impedance or the resistance on the line. We can make it, from a synthetic standpoint, higher or lower, and we push and pull power flow across the existing grid. We can balance out the load, and we can add capacity. In this model we did in the UK, on this specific circuit, it added 500 megawatts. Pretty big wind farm. So what are we doing? We have some key advantages, I would say. Very quick integration of renewables and new loads. We're really improving the grid flexibility, reliability, and resilience. And we're, I would say, in a much, much bigger way than any other technologies out there, impact now. This, as I tell anybody that will listen to me, is a politician's dream. It means you can add capacity and do something very significant, typically within 1 or 2 years. There's not many other technologies that will do that. If you want re-election, depending on where you are in the world, I think to show that kind of impact is a pretty big deal. So as I look at the outlook for growth, I'd step you back through the applications, services platform. These are the big step changes we see in the market. We're obviously, as a company, at the beginning phase here in the applications, very specific need cases that we model the smart valves for and deploy. There's a $6 billion pipeline that we're tracking right now. Specific projects, known scale and size, known deployment date, known location, et cetera, et cetera. These are committed capital plans for system operators across the world. So that really is about, for us in the near term, really the conversion of that opportunity. Moving then beyond that into the application of services layered on top of the technology. And as I said, the ultimate is to make sure the grid gets this digital paradigm or a digital platform. Again, I think this is going to become a super interesting time for energy when the grid really is at this point. How much innovation can we unleash on both the generation and the demand side. So adoption, scale, and then gradually transitioning to more of an annuity-based revenue stream. So what's that looking like today? I'll give you 3 examples. In the UK, we did a large project for National Grid last year. We added actually in that project 1.5 gigawatts. It was 43 smart valves, 5 locations, 3 circuits. Saved the consumer 400 million. We have expansion projects with them this year. And then we can see with the capital plans, we see a large number of projects coming on a yearly basis for the next 5 to 10 years. In Colombia, a super interesting region. Again, we've worked with most of the system operators in Colombia. We've solved some very unique and interesting problems, and sometimes, in fact, even getting cheaper, cleaner power to regions that are more, I would say, affected by poverty. So there's a nice social benefit there as well. But again, expansion projects this year, expansion projects next year, not just Colombia. These customers are now taking us in to Peru, Brazil, Chile, Bolivia, and so on. And then lastly, just to talk about Australia, again, repeat business, unleashing new capacity for renewables, saving money for the consumer, and we again have expansion plans this year. So this is all about platform adoption and how once we do a project, we see this repeatability with the customer year over year. So we're positioned for strong and sustained growth. We're obviously focused very much on creating this digital grid solution. Our technology is patented. It is transformational. We're thinking about, obviously, as a company, industrialization and scale. It's super important as a business. We're very professional in the way that we drive our business, the way we operate, and that as we hit that tipping point of adoption, we can scale rapidly. And as we evolve, we know that the platform will drive to more annuity revenue streams. We're much more of a project-based technology sale business today, but we see annuity streams evolving, I would say, in the midterm. And let's be real about this for a second. This energy transition that we're working our way through, we've been talking about it a long time. I was in wind for 10 years, but I can tell you we've scratched the surface. We're not even close to doing what we need to be doing. And what's coming is going to be, I think, incredible. The scale and pace of adoption of renewable needs to go up 4x, as I mentioned earlier. I think the stuff we'll see on the demand side, on the distribution side, will be super interesting. So get ready. If any of you remember the telecoms of the late 90s versus what it is today, think about that change in this space. That's what's coming. So thank you for your time.
Thank you very much, Robert. Question, main challenges for this year, 2022, for you?
The same ones as last year. So that would be, obviously, technology adoption. We still continue to work with utilities to adopt the technology. And moving that utility customer segment forward can take time. So that's one of them. And then the other piece is industrialization. Supply chains and logistics are still really tough right now. The Russian invasion of Ukraine probably doesn't help that a whole lot either. So these things are the things we worry about the most. Yeah.
So in terms of what you would dream of, or what you need in order to really transition forward quicker, what would that be? Is it legislation or is it more funds? What is your primary design here?
So two things. Yeah, that's a great question. So two things. If you look, and I didn't mention this in the presentation, but often if you look at market design, it's quite ironic that market designs in different countries don't always incentivize the utilities to be the most progressive. And in many ways, they sometimes do the opposite. So the irony of the market design versus what we need in energy transition is not lost on me, and it shouldn't be lost on you either. It's pretty bad. And in some countries, I think it's borderline criminal. You know, just the way it's set up is pretty bad. It's evolving and changing, and some countries are being really progressive now and really pushing it, but we have to keep an eye on that. This repower push for Europe now to move away from dependency from Russia, you know, there's things you have to do to make that real, and it's not the technology. It's often the market design, so that would be the first and foremost. The second one is a cultural thing, and I often think of I think the environment within our customer segment it's such a risk adverse, for good reason. They have mission critical assets, but very risk adverse. And often I think of the engineers we speak to as the no engineers. And so how do we change the no to a yes and get people to think about what they can do to make these changes happen?
You mentioned the IT transition and the similarities. Is there anything we can learn from that and putting it to this new field that we need to transition quicker into?
Yeah, so very different spaces, and I think the pace and what we're going to be able to do in the grid will probably not be as radical as we saw in telecoms and communications. But I think the biggest single lesson to learn is that probably the pace and just the breadth of change that came was so surprising and so fast, and I think that's what we should expect on the grid side as well.
So we need to hold on to our hats.
Yes, let's do that.
Thank you very much, Robert.
You're welcome.
Thank you. It is now my pleasure to introduce the CEO of Midsummer. And Midsummer is a Swedish company that focuses on mass production of solar, on flexible solar cells with high production rate and very low carbon footprint in the production. So please give a warm hand to Sven Lindström. Welcome, Sven.
Thank you. My name is Sven Lindström. I'm one of the founders and the CEO of Midsummer. So first I'm going to show you a picture you're probably familiar with, but today the world releases over 30 gigatons of carbon dioxide per year in the world. We saw a small dip due to the pandemic, but after that, when production started, it came back up to the same levels again. And it will continue to increase as we invest more and more to build these new green factories and invest in new renewable energy production. So that's why whatever we do has to be really energy efficient. And you're probably very familiar with the Swedish and also the European electricity prices. So being energy efficient also means being profitable. So that's very important. This is the blue bars here is the Swedish Energy Agency and what they expect, how much they expect the electricity demand to be. So the electricity demand in Sweden will rise due to that we're switching the transportation sector to electricity, etc., etc. And the blue bars is the base scenario. The gold or yellow bars is in case we continue on this path of switching to the transport sector to even more electricity. And I think that's a given, the way it looks like today. And the way we're going to supply this demand, according to the Swedish Energy Agency, is this. So in the bottom you see the Swedish hydropower, and the brown is nuclear, which basically stays the same or actually decrease a little bit. And the light blue bars is wind. But I don't think that wind will be able to grow that fast. You know that there is a lot of protests. People don't want windmills close to their houses and in view of their house. So I think the real answer to how to meet this demand from the electricity sector is solar cells, to produce electricity where it is consumed. So you produce electricity on each and single roof, and especially these large flat roofs on top of factories. That will be a given in the years to come. So for this we have a very good solution, but I'd like to show you how energy efficient our solar cells are. So on the bar to the left, you see how much carbon dioxide is released for every kilowatt hour of electricity produced with coal. So if you produced 1 kilowatt hour of electricity with coal, you release between 800 and 900 grams of carbon dioxide to the atmosphere. And then you have oil and natural gas. And then you have some renewable energy sources, which I enlarge here. And to the left, you see traditional silicon solar cells made in China. They release about, on a life cycle analysis perspective, they release about 50 to 60 grams carbon dioxide per kilowatt hour produced. The lowest two blue bars is wind and hydropower in Sweden. So if you produced 1 kilowatt hour with wind power or hydropower in Sweden, you release about 10 grams of carbon dioxide per kilowatt hour produced. The yellow ones are solar cells from Midsummer. So if we install them in Stockholm, over a life cycle, you release 6 grams of carbon dioxide per kilowatt hour produced. If we install them in Sydney or Los Angeles, we release about 3 to 4 grams of carbon dioxide per kilowatt hour produced. So this is the most sustainable electricity source known to man. And why is that? So here is a traditional silicon solar cell. When you manufacture silicon, you actually take silicon dioxide, which is quartz sand, and you let it react with coal. The byproduct is carbon dioxide, and you end up with pure silicon. So even before it turned into a solar cell, you have released quite a lot of carbon dioxide. And this is very fragile, so it breaks like that. So that means you need to protect it with a quite thick glass and an aluminum frame. Both of these products release a lot of carbon dioxide when being manufactured. At Midsummer, we produced thin film solar cells. So the light absorbing layer in our solar cells is only 2 micrometer thick. So we use extremely little material. We deposit this on a stainless steel substrate, so it cannot break. We don't need a glass, we don't need aluminum frame. So that's why we have an extremely low carbon dioxide footprint. And this is a technology that we have developed over the last 17 years. And we're the only one that can mass manufacture these type of cells in the world. Down to the right, you see the production equipment for these solar cells. This production equipment we make ourselves as well. So we make it just outside of Stockholm in Järfälla. And we also make the raw material that we put into this machine. So we have the complete value chain from the raw material to the production equipment, to the production of solar cells, to the production of solar modules, and to the installation of the finished product onto roofs. So I'll show you a little bit what it looks like. So because our cells are lightweight and flexible, we can adapt them to any kind of roof structure. In this case, you have the most common roof tile in Sweden, where we have bended our solar panels so it fit exactly. You can hardly see that this is a solar roof. We also have another product which we call Midsummer Slim. And here we have a standard tin roof. And we actually make this tin roof also in our factory in Järfälla. We buy the coated steel from SSAB, and then we integrate the solar panels already in our factory. So when you install these kind of solar cells, or when you install the roof, you already have an installation in place. But I think the really large market is what we call Midsummer Bold. In this case, we have a panel that is exactly the same size as regular silicon panels, 1 by 1.6 meters. And we lay them flat onto these kind of factory roofs. This particular building is an installation in Flen. The building is made in the 70s, so it cannot really handle the load of snow in the winter and traditional silicon solar cells. So the owner of the factory, he really wanted to be able to go up on the roof in the winter time to shuffle off the snow. And on Midsummer solar panels, you can walk on them, and you have no constraint. You don't need to penetrate the waterproofing layer when we adhere it to the waterproofing layer. So and you don't hinder access to the roof at all. So these are our products, and we have a very high demand for these products, especially in the wake of the ever-increasing electricity prices. As I told you, we have a factory in Järfälla. You see the picture to the left. And then we recently got a lot of support from the Italian government to start a factory in Bari in southern Italy. So for this factory, we got a 23 million euro grant from the Recovery and Resilience Fund in Italy. And we also got a 15 million euro soft loan from the same facility. The most expensive items that goes into this factory is our production equipment that we make in our factory here in Sweden. So we will be able to make this, to build up this production capacity in Italy in a cash flow positive way. And the factory in Bari will have a 50 megawatt nameplate capacity when it's finished by the end of this year. But this is only the beginning. So what we really want to do is to expand factories further in Sweden. If we look at the 100 megawatt factory, we would need 10,000 square meters for this. We can install our equipment in any existing industrial building. A 100 megawatt factory would employ about 1,000 workers in the factory and 1,000 installers for installing the roofs. As I said, it would have a production capacity of 100 megawatt. And the energy consumption of such a factory, it's only 0.05 terawatt hours per year. And that should be compared to, for example, the factories or the total consumption in Sweden, which is 150 terawatt hours per year. So it's a very energy efficient process. This factory, the output of this factory would in 10 years generate 0.8 terawatt hour per year. 10 of these factories would generate 8 terawatt hours per year. That is half of the increase that the Swedish Energy Agency foresee in the coming 10 years. So this is really what we want to do, and to build these kind of large-scale factories all over Sweden. And since we can use existing buildings, we don't need to start with a green field. We can move into any kind of factories where, for example, Electrolyzers, Whirlpool, or some other companies have moved away their production. And we can utilize that facility, and we can get going in a very, very short time. By producing the electricity locally on top of factory roofs, you're actually relieving the grid. Because if whatever production you have, either if it's from a nuclear power plant or from a wind power plant, you need to rebuild the grid, and you need to strengthen the grid to handle all of that electricity input in one spot. But by using solar power on each and single factory, you can actually produce the electricity exactly where it is consumed. The benefit of that is that you don't need to strengthen the grid in order to handle this. What the grid operator will see is only that your factory energy consumption is lowered. So I think this is really the way to the future. It's not the only solution. We need to increase also wind and other renewable energy sources. But this is one part of the solution that will create a lot of local jobs. If we look at 8 terawatt hours and how much carbon dioxide that would emit if we use, for example, the electricity mix from EU, you would release 2 million tons of carbon dioxide. If you use the electricity mix from Denmark, it will be a little bit lower. From Germany, it would be a little bit higher. if you use the electricity mix in Poland, you would release 5 million tons of carbon dioxide into the atmosphere. If you use traditional Chinese silicon solar cells, it's a little bit lower, wind as well, and Midsummer you can hardly ever see on this scale, because the carbon dioxide footprint from the production is extremely low. And this is, I think, the whole world is realizing now that we can't be reliant on oil and energy sources from one-party states in the East. And the European Union has a new initiative which they call Repower EU, where they want to break free from the dependence on Russian oil and gas. And this is exactly what we see as well all over Europe. And in Italy as well, they import around 40% of their natural gas from Russia. And that's 29 billion cubic meters per year. So we think that we can be a part of the solution to break free from the dependence of carbon dioxide what do you call it? Oil and gas dependence, and also be a new energy driver for creating energy and a lot of jobs and local demand in Europe. So that's pretty much what I had to say, and thank you very much.
Well, thank you very much indeed, Sven Lindström. A question here, in terms of patent, what does your patent protection look like? This is a very unique product you have.
It is, and actually we have taken a strategy not to use that many patents. We do have patents approved in Sweden, in US and in China. But to reverse engineer our solar cell, it would be very difficult. The secret is how you manufacture this. And when you see a finished solar cell, you don't really know how it's manufactured. If we were to take patents, we would have to tell everyone exactly how we manufacture these solar cells. And there is more into that, because we manufacture the raw material to the solar cell ourselves. We manufacture the production equipment ourselves. And all the production data in terms of the temperature, the pressure, what kind of gases and material to use, only Midsummer knows. And we are the only one who knows what kind of purity the material needs to have, etc., etc. So that is only known to us. So I would say it would be extremely difficult for someone to copy our IP and technology.
Thank you. When you meet a customer and install the panels on their roofs, or a company or industry, how do you work with battery capacity in terms of storage?
Yeah, so we don't manufacture any batteries ourselves, but we do work, and lately there has been quite a lot of demand into battery for storage and backup, and we offer different solutions that's available on the market. So I think that's a very good way, and I use it myself at home.
So it's basically one-stop shop. If you contact Midsummer, you also get help with the battery installation.
Yes, of course. Yes, so we integrate everything, and in many cases, when we install the slim roof, for example, we also do the roof renovation, so to say.
Well, excellent. Best of luck, and thank you very much, Sven Lindström.
Thank you.
Thank you. All right. Exciting indeed. So now it's time for a panel discussion. We're going to talk about biocarbon and the decarbonization of the Swedish industry 2.0 towards the SDGs. And I'm now going to hand over to a colleague here, another moderator. But first I'd like to introduce the speakers here in the panel, the participants. It's Clara Hellstad, head at the Sustainability Industry Unit at the Swedish Energy Agency. Welcome, Clara. Please take a seat. Gustav Melin, CEO at Svebio. Please join us. Thank you. And also we have with us Lars Gunnar Almryd, who is CEO of Envigas. Please join us here. And the moderator, of course, Rafael Guedes. You are researcher at the Heat of Power Division of the Energy Department at KTH, and you're also a Naventus Energy, Renewable Energy Advisor. So I hand over to you, Rafael.
Thank you, Katarina. And thank you all for joining us today. So I hope we have a nice discussion, and I will clarify. We'll talk about biomass in general and how biomass can serve towards decarbonizing or meeting our Swedish targets, right? Being carbon neutral by 2045 or so forth. Some key notes there. I'm sorry that I have my phone here, my notes here. It's not that I'm waiting for a message. According to the IEA report recently published last year, roughly 60% of the energy consumption in Sweden comes from biomass. And that's a shocking message because usually we refer or think about renewables and think about electricity and that most of our electricity is hydro or nuclear, etc. But you know, energy is consumed in Sweden to a large extent in heat. And then when it comes to heat, if we put aside heat pumps or the electrification path, those that come from fuels or related, I mean for heat, almost 70% comes from biomass today. So that is our background. And then I want to discuss then, start talking about, well, with the experts here, like where are we today, why are we there, and how are we going to move into the future? What are the roles of biomass coming next? And the challenges, of course, and how we can, well, try to make the policymakers, decision makers, or investors try to make us reach there then, right? So I'll start with today, and I think when I say, you know, that biomass is, or bioenergy is widely used for heat in the industrial sector and district heating, and I'd like to hear maybe from Clara, since you're very familiar to the industrial sector, which are those sectors in the industry that today harvest biomass, and which ones you see coming up?
Well, of course, if we look at the situation today, the forest industry, the pulp and paper industry is a very large share of the, they use a lot of biomass, of course, as a part of their main products, of course, but then the final energy use within the industrial sector, well, half of it is used in the pulp and paper industry. So we have a strong history from the raw material from the forest, of course, in Sweden. But what we see today is that other parts of the industry is more and more looking at the biomass as a way to reduce their emissions. So, for instance, I would like to mention the iron and steel industry, which have a large share of the fossil greenhouse gas emissions in Sweden. They're looking, for instance, as bio-oil. I would like, for instance, hybrid initiative. Perhaps you have heard very much about the hydrogen part of the hybrid initiative. But I also have a bio-oil pilot in Malmberget for the pelletization process. And actually, that pilot has been very successful. So they are already implemented in the pelletization plant in Malmberget. That is only one example, but of course, biochar or biocoal is necessary in the reduction process in the iron and steel. If you want to make steel, you need some kind of coal in the process, and that we could see the biomass as one step. And then we had the chemical industry and the refineries, for instance. You could look at the case of Perstorp, the chemical industry. And of course, they will use both renewables from and other fossil-free solutions. So it's a mixture if we look around among different industries in Sweden. And things are going quite fast now.
That's for sure. Yeah, we see every day in the news how, you know, renewables everywhere, of everything moving fast. So interesting. So pulp and paper, that we knew. So that's our
that's the base, I would say,
in Sweden. But definitely good to hear from you, all the other sectors that are moving and that are also considering biomass already now and in the upcoming. And we will talk about future and hydrogen and so on in the next questions. But before that, I also wanted to hear from you, Gustav, maybe on the what are the main challenges today? You know, if we see this all these opportunities, right? And we're clear that already today, even 60% comes from biomass in terms of energy consumption. Is there a limit? Are there challenges? Are they political? What are the limits? What are the challenges technical to realize this?
Yeah, I could start to give some more light to the political background, or the background why 40% of the energy use is biomass in Sweden today. So it's the largest energy source, larger than hydro and nuclear together, even though it's mainly heat. But the reason why we have 40% is that we have no fossil domestic fuels. I would say we have a large forest, but we have no fossil domestic. We have no company representing the fossil sector, so to say. We have our conflict in Sweden with the nuclear. So it's nuclear or renewables. That's the conflict. But we have had no conflicts on the fossil side. So that's why we have developing the renewable side and biomass side over the years. And we had the carbon tax from 1991. So it's more than 30 years now that we have had a carbon tax. And it has been on a high level. So that's why we have found a lot of different good solutions without subsidies. But going back to to your question then, what are the problems or the obstacles to reach for the future? And I'm a bit different than other people because I have, or I know I have this thesis that the biomass is not limiting for the development. Most of the people globally believes that there is lack of biomass. In my 35 years in this sector, it's only 1 year that we have problems to deliver wood chips, and it was in 2001. And the reason was that Stockholm was full of snow. It was this snow pilot or snow canoe from, some of you remember that. So it was 1 meter in 1 day, and it was a cold winter. So then we had problems. But otherwise, all other years, there is lack of demand for biomass or biomass volumes. So our main problem, it's not technical. There are technical issues. We need to do more research, of course. But our main problem is the narrative, the belief that there is not biomass enough. There is a food issue in the world. The NGOs that try to push this picture all the way that it would be better for nature if we don't touch the forest. We will have higher biodiversity if we don't touch the forest and so on. I think that's the main problem. And then that influences politicians to be negative to biomass development. I mean, we are not allowed to use energy crops, more than 7% of the energy use in Europe because of the EU legislation. But you know, everyone knows that there is no demand for more crop production in Europe. There is a lot of closing. We have been closing down arable lands since the 80s in Europe. And actually, the last 60 years, the food production per hectare is higher than the population growth on the whole globe. So it's almost 2% increase in production per hectare, but the growth of the population is 1.62% for the last 60 years. So, but we don't believe the data. We have a narrative that we believe in, which is mainly running the policy. So that's, I think that's the main problem.
The main roadblock, according to you. And anything to comment here, Clara, Lars-Gunnar?
Well, I would say that the policy and regulations issues are really important. And right now, in the European Union, there are different directives under revision, and it's important to engage in those revisions and be careful and see all details, because of course we have a different situation compared to some other countries in the European Union. They have had large deforestation earlier in their history and have a completely different type of landscape than we have in the Nordic countries, I would say. So we have to be careful and look at the revisions, I would say, of the RED directive, for instance, and other directives, because it affects both bioenergy, but also when we talk about electrification, it's also what is fossil-free electricity or renewable. It's important. Each of these words could affect
Definitely, or what is sustainable to come.
Exactly. Yeah. So.
And I agree. Usually, I mean, as a researcher, the issue with biomass that comes to mind when developing new technologies or let's say expanding biomass, it always comes to feedstock or prioritizing. Is it food or is it the energy or so on, right? So it's interesting to hear from you your perspective for so many years in the industry, saying that there is not such a thing, or critical at least, in terms to believe that there is a shortcoming of feedstock and that we could further exploit that. That's what I'm getting. Right? Anything to add there, Lars?
No, but I agree to Gustav when it comes to the historical facts, but I think we have to be a bit humble looking forward, because we don't know what will happen as an effect of the climate change effects. On one side, the trees will grow faster, which will make more biomass, but on the other side, it creates also worms and diseases and fires and so on. But there is also a huge transformation going on in the industry, and the use of biomass, as we will discuss, which will create new users. So I think we have to be a bit humble when looking forward, and at least take into account that we need to use and utilize the raw material in the best and most clever way.
Yeah.
Efficient processes.
Yeah, exactly.
Because we have a lot of potential still in the Swedish industry, and of course in other countries as well. We have still too much, well, we could be much more efficient in many different processes. And also, of course, more circular solutions. We could use our raw material much more than we do today.
So I'm hearing, a lot of like, we could do. So let us move into what are we, we talked about where we are, the industries that are doing it, obstacles perhaps. So, and Lars Gunnar mentioned, what comes next. And to me, when I do a small research, I think, well, not to me, but anyone that goes into a small research of what's happening with biomass, besides the established, heating part on pulp and industry and so on, I think three things come to mind in looking into the Swedish sector. One, it's the integration of carbon capture in the combined heat and power plants that are run by biomass. That's one thing. The other, it's on biocarbon, like you mentioned, and its potential role in the decarbonizing fully the steel industry. And the other, it's on, and it's also of my own curiosity, like, don't we see also an opportunity for biomass in the hydrogen industry in general? I mean, you can still produce hydrogen from biomass gasification, for instance, or other processes. So I'd like to address these 3 points. It's challenging in time, but let's start with one of them. So let's start with the carbon capture part and combined heat and power plants. So combined heat and power plants today still serve an important purpose in Sweden. I mean, they are 8% of the electricity, roughly, and provide a big part of the district heating, heat, right? So what about, can Gustav, Clara, or any of you tell us about what is this technology and how will that enable us to be at the forefront of this, by Stockholm Exergi being one of the front leaders now implementing it, and what does it mean to us?
Well, actually, that is, of course, an area where the policy issues are very important, because bioenergy, carbon capture and storage, we want to reach negative emissions in the future. And then we are looking both on the heat and power plants, of course, and also the forest industry, which have a very large share of the biogenic emissions. But today, of course, you need a market to have a kind of a pull in this pull in the system, and that is one thing where the Swedish Energy Agency has. We have done a lot of work the recent years and sent a report to the government and suggest a system for how we could have this market pull from a policy perspective. And of course, then there are some of our neighboring countries which have a tradition from the oil and gas industry. And so we are looking at the bilateral possibilities to, in the future, find logistical solutions to export.
Okay, so you see it as the roadblock comes more from, okay, we have a technology that is being demonstrated, right? Yeah. But then we have a roadblock, which is, what do we do with that, right? We need to develop the market for CO2.
Well, of course, you need a price, because it costs something to install the equipment at the heat and power plants. And of course, you need a market, and that is what the political, political part of the work. You need something. You need a price to.
So that you can recover that investment. Anything to add here?
Yeah, I think so. I mean, the first thing you think is to try to put it into the emission trading scheme. I mean, the price now this week was 78 euros per carbon dioxide ton. So then there is also a proposal in the EU Fit for 55 now to increase the annual decrease of the curve from 2.2% per annum to 4.2%. So rather big increase on a high price already. So if they do that, I think it could be a good timing to include bio-CCS in the EU ETS system. So a part of that 4.2% would be bio-CCS and then priced, so that you could get today then 78 euros. And I think that's a level that can work for some of the companies, and some of the companies would still need some support, subsidies to develop technology. But I went to, we should have Fabian Levin today in this panel, but he got COVID. And then, and we were there visiting his plant in December, and he told us that they use the same technology that they cleaned the gas, the city gas with 20 years ago. So it's known technology. He has taken different kind of equipment from the shelf and put that together, and it works quite well.
Okay, so then come to the same point, like, so it's not, the obstacle is not technology, but again, then policy.
It's the market.
The market and
like for
policy.
biomass as a whole, it's more the market issues.
Good. And let us move to the other point then that is also happening in Sweden, and you know, Sweden is going to be at the forefront. 2030 we will be delivering carbon neutral or fossil-free steel, right? So what is such a thing as fossil-free steel, and how that biomass plays a role in that picture? Is it needed? Lars Gunnar, we start.
Yeah, definitely. I mean, whatever process you will use going forward, it's a big transformation going on in the steel industry, but whatever process you will use, you will need carbon atoms in this process, mostly for process reasons actually, but also for quality reasons of the final product. So carbon is needed, and if carbon is needed and you don't want to use fossil coal, then biomass is the solution as we know it now. So that means that biomass will play a role in this if we really want to make fossil-free steel. If we want to make almost fossil-free steel, then we can live without it.
But our goal should be 100%.
Yes,
so
sure.
Then we should have biocoal. Anything to add, Clara?
Well, no, yeah, I share the same view actually. So we could see a couple of examples, and of course it's easy to perhaps only focus on or only see one example maybe, but we could see many different processes in the iron and steel industry that actually you have a little bit different technologies, but still you need the biomass or biochar in some parts of the processes.
Good. So then we come to maybe, like I said, my own curiosity. And how do you see biomass and its role in the hydrogen ecosystem, right, or the hydrogen energy ecosystem? So right now we just hear about how everything new hydrogen strategy, hydrogen regulation at EU level, hydrogen everywhere, all driven by electrolysis. But we have technologies existing, not to be demonstrated or proven so much, that from biomass that allows us to have hydrogen as well. I'm a believer that we cannot just all shift to electrification everything, and that biomass will play a role there even as well. What do you think there?
Well, I mean, one of the reasons why people are so happy with electrification is to get rid of combustion and emissions and so on. But I think there is, we shouldn't be so scared of combustion. It's very natural. I mean, there is no living cell on this planet without respiration, or which is the same process as combustion in a engine or a boiler. So it's very natural. You eat biomass and you work with your hands and so on. It's combustion in your cells. You in Swedish you say that when you're out running, you go for förbränning, or you could say that when you should burn some carbs. That's what you do when you run. So I mean that's what we do. So it's not more strange. It's the only issue is to get rid of the bad emissions, and we can do that with modern technology. It's not difficult. But of course, since you believe that it's always carbon emissions when you use combustion, or if you believe that it's, I mean, all of us are experienced with bad emissions. So we need to get away from that, but we shouldn't mix up that with modern combustion. And then there is a great potential for a lot of different solutions. And I think that those companies that are in this sector is very interesting, and I believe that most of the combined heat and power plants will start to do either bio-CCS or some kind of pyrolysis carbon production investment. Because what they can do, I mean today the combined heat and power plants, they go for 4,000 hours a year, and if they would invest in this sector, they could start to use their plants 8,000 hours a year. So, and then they should produce, in my view, like they do in Gävle now, in Setra, they produce pyrolysis oil to deliver to Preem, to produce biofuels. And they do that from sawdust 24/7, all year round. And most of the combined heat and power plants could do that. And then so you get 40% roughly out of the energy in the wood chips, in the pyrolysis oil that you could go for the biorefinery or use as peak load heating bio oil. And then you get you can get the coal, either put it into the combined heat and power plant and produce electricity and heat. You do that all the winter time, but in summertime you can produce coal like Envigas and sell that to the industry. And you can go in and produce electricity if needed during summertime. So there's a perfect match here between
everything there.
More hours, you can produce oil, biofuels, charcoal, and electricity. So you actually you solve all the issues in the electricity system.
So we can tell you represent Svebio, and you very well sell biomass as a whole.
So
and you see biomass in all the sectors.
I believe more in that development than in the electrification development, because it's cheaper.
Okay. Anything to add? And just
lower cost.
I think it's extremely interesting to see if you could produce or you can produce hydrogen from biomass, but there is some technical steps before you have it commercialized. But there is, of course, an opportunity also, for instance, for the local grid. If you add a fuel cell onto that, and you could have your own electricity production and so. So I think in this combined, transformed system, it's a very good opportunity of also potentially producing very cost-efficient hydrogen compared to the existing solutions.
I agree.
Potentially.
Yeah, I agree. I mean, it's all potential. And before giving the word to you, Clara, I'll say, I also think biomass, I mean, one of the challenges the hydrogen energy ecosystem have for industry is hydrogen storage. And the use of biomass as a fuel can be actually a way to store hydrogen from one production facility to where it's used, for instance. But Clara, anything to add as a last comment on this topic?
I just think that sometimes in the debate or in media, perhaps you are focusing only on one or two technologies, but of course there are many solutions that actually is needed. And you have to have both a short-term perspective on these matters, but also a very long-term perspective. So maybe some of the solutions are possible to implement in 2045 or even after that, but we need to do things now, but we also at the same time have to focus on the future far ahead. So I would say that if we look at an industrial plant already today, I would say that most of the cases they use already today a mix of different solutions. And it's just that perhaps it will be a different mix in the future, and you have to see that the whole system somehow is changing now, and we will get new connections between different parts of the industry. Maybe new circular solutions are developing, which you can't really, well, you can't stop the things.
Can't know for sure now.
No.
Well, I think our time is up, but it was a pleasure to moderate this session. And if I'm to summarize, I mean, we are firm believers that biomass has a role to play. Biomass, one key message people should know is biomass does play a role today that is very important because it's more than half of the energy final consumption. And we believe it will still be there in the existing sectors and possibly even more. And they're talking about the role of biocarbon in steel, in the hydrogen industry, and potentially as in the CHP plants of the future to provide even other services. So thank you very much. It was a pleasure. And thank you all for listening.
Thank you very much. Thank you.
Well, thank you very much indeed.
Thank you, Katarina.
If you are interested in hearing more about the EU renewable perspective, Frans Timmermans is coming to Stockholm on April 1st. And I have the honor of sitting with him for an hour plus and moderating a conversation. And this will all be aired on the We Don't Have Time platform. So if you want to hear directly from Frans Timmermans about the renewables transition in Europe, just tune in to We Don't Have Time on April 1st. It's in the morning, but it will be recorded, so you can watch it afterwards. Now we need a break. We take a coffee break for until 25 minutes past 10. So see you back in a bit. Thank you. Welcome back. Please take your seats. It is indeed wonderful to see people mingling here at the Grand Hotel. But we need now to continue with the program. So please take your seats. The next company to present is Climeon. And Climeon produces heat power systems, converting waste heat and geothermal heat into clean electricity. So now please give a warm hand to the CEO, Lena Sundqvist.
Hello, I am Lena Sundqvist, and I took over as CEO of Climeon in August last year. And we all know that we need more sustainable power in this world, and that is what this conference is all about. And we've heard about a lot of really good alternatives today and really good technologies like wind power, solar power, biomass, hydrogen, and really good technologies, all very much needed, but they all also have their limitations. And as we heard also in the panel discussions just before the break, is that not one single technology can solve this whole situation, that we need more electricity and we need fossil-free and sustainable power. And Climeon's contribution to this world of more sustainable power is heat power. So what is then heat power? Heat power is actually electricity from heat. And in the world, there is a lot of heat which is not being used today. For example, in all industrial processes, there's a lot of waste heat. And on board ships and in power plants on land, there's a lot of heat just being wasted. So in a lot of industries and on board ships and in power stations, normally of the energy you put in, more than 50% of that energy is just wasted as heat, not being used today. And this heat can be converted into clean electricity, and that is what Climeon is doing. So our product is, in general, it's an organic ranking cycle, but with a very high efficiency. And we use low temperature heat, around 80 to 120 degrees. And we also need a cold source. And this cold source could be any cold source. It could be a river, it can be seawater, it can be cooling tower, or it can be dry cooling. And what's happening in our product then is that we take in this heat. Inside our product is an organic fluid. And that organic fluid is heated up, it is evaporized, it goes through a turbine generating electricity, and then it's cooled down and condensed, and it's a closed loop within our product. And the product that we have today generates 150 kilowatt of energy or electricity. We have a number of installations today. We have more than 30 units installed on board ships. For example, on Virgin Voyages passenger ships or cruise ships. We have them on board Havila ships trading along the Norwegian coast. We have them on board 2 Viking Line vessels trading here in the Baltic Sea. And we also have 1 unit on board a Maersk container vessel trading globally. We also have 1 installation on a steel mill in Sweden, or a steel factory, and we have geothermal installations on Iceland and in Japan, generating continuously clean electricity from heat. So where do we focus going forward? One market that is very, very interesting for us and that we have a big focus on is the maritime market. Shipping is one of the most efficient way or with lowest carbon footprint to transport goods. Still, the shipping industry is standing for around 3% of the CO2 emissions in the world. So there is a big drive for this industry to cut CO2 emissions. And this industry and the International Maritime Organization, they have set up targets to cut CO2 emissions by 2030 with 40% compared to 2008 years level. And already next year, from 2023, ship owners need to classify their ships according to an energy efficiency index. So there is a lot of legislation now driving ship owners and also then shipyards to lower CO2 emissions and making their ships more energy efficient. And in addition to legislation, all ship owners also want to cut fuel cost. Fuel is one of the biggest cost driver for a ship. So, and now when the fuel prices is only going in one direction, there is more and more incentives for ship owners to cut the fuel cost. And when we talk to ship owners for installing equipment, they want to normally have return of investment for 5 to 7 years of whatever they put in. So that would be including our units, installation, and operating cost. So that is what we're working with together with ship owners, and we're getting more and more inquiries all the time. And in the world, on average, of course it varies from year to year, but in average there is 1,800 ships, big ships, being built in the world, the majority in Asia, of course. And of those ships, when we look into those, around 30% of those are relevant for our type of equipment. And the bigger they are, with larger engines, more fuel consumption, of course, there is a better business case for the ship owners to reduce fuel and fuel cost on board. So a lot of initiatives and a lot of focus going on in this market, and there is a big drive to both cut fuel cost and cut emissions. Another really interesting market for us is power stations. And one country that we're working with is UK. Like in most countries in Europe, UK say that the need for electricity is going up at the same time as they want to cut emissions. And all different countries in the world and all different countries in Europe have different situation. But in UK, they have a lot of wind power. And but when you have wind power, you also need to have sustainable baseload power. In UK, another thing that they have is that they have a lot of gas. Not Russian gas, but the majority of the gas is from the North Sea. And one project that we're working with here is a company called Denmark. They have now started to construct their first plant, which is engines combusting gas, then putting our equipment and other equipment beside or to the engines, increasing the efficiency of this plant, increasing the output of electricity, and then they could put carbon capture at the end of this, making this into a green source of baseload power. So the first project now with our equipment on it has been started to be constructed, and then we're looking into the next and the third installation together with them. Geothermal power. Personally, I think geothermal power is a beautiful way for the world, or a beautiful alternative for the world to have more sustainable baseload power. Geothermal power is already in use in several countries in the world, like in New Zealand, for example. They use a lot of geothermal power in US. Normally, this is big installations. They use temperature around 200 degrees. In Climeon, we are focusing on low temperature installations and also smaller and distributed plants. So we have installations in operation on Iceland and also in Japan. However, geothermal power is quite immature. It has not come as far as wind and solar power, but there is a lot of initiatives going on in the world now to develop geothermal power. A lot of initiatives with drilling, constructing, building the plants, operation of the plants. So this could be a really good alternative for the world to have more sustainable power. And not so much here in Sweden, because we don't have so much heat close to the surface, but in a lot of other countries, and also in countries in Europe, like in Germany, for example, they have better options for having more geothermal power. So this is something that we are following really closely, and could be a really good alternative for the world. As I said previously in my presentation, we have one product today which can produce 150 kilowatt of power. And this one you can put in serial production or parallel production if you want to have more electricity. But what we are working with now also is the next product. And it will be a larger product, heat power 300, so around double the size. It will have the same advantages as our product that we have today. It will have really high efficiency. The first product version of this will be designed to meet the maritime requirements and the requirements on board ships. But then this can also be designed for also meeting land-based applications, like the one you saw in UK, for example, or geothermal plants. Then we need to get rid of the special marine requirements and put in more land-based requirements, but that will be quite easily adapted. And this would be a customer's product platform, so it can be easily adapted to different market requirements, and it will be launched during this year, and then before that launch we will then obviously come back with more information about this product. So just to summarize this, heat power is a part of the puzzle to having more sustainable power in the world, producing fossil-free electricity. There is a lot of heat available today which is not being used from industrial processes or on board ships or even underground, which can be used as geothermal power. We have a product in operation today in different market segments and in different places in the world. And this year we will also launch a larger product. And we will then come back with more information before that launch. Thank you.
Thank you very much, Lena Sundqvist. In the maritime sector, we are now seeing big ships that have added on or built on or been produced with this sail function.
Yep.
How is that connecting to your product in terms of heat recovery?
I mean, that is one alternative for reducing CO2, obviously. But I think there is very, very few ship owners that could see themselves only having a sail. They would need an engine as well.
Of course.
So for a long, long time, there will still be engines on board ships. So
it's not competition. It's basically just an add-on for some ship owners.
Ship owners need to look into several alternatives to cut CO2 emissions, so that also there's just not one single alternative. There's a lot of different things needed to cut CO2 emissions.
Thank you. So if we look 5 years into the future, where is Climeon?
Yeah, we definitely have. I mean, now on the table, what we have now is to launch this new product and get that on the market. And with that, we will have that product, of course, on many, many more markets, like more established on several markets.
And how about competition in your field? What does it look like?
There is, of course, competition, both if you look at other companies with sort of organic ranking cycles or heat power equipment. Either they normally have, there's different alternatives. So in geothermal power, for example, there's usually larger installations, whereas we have smaller, more distributed power. And that market opportunity is so huge, so there will be room for all of us. If we look at the maritime market, there's only us and one more supplier marketing ourselves in the marine market. But of course, we think we have the best product and we have the highest efficiency. So I think we need more suppliers to develop this market, and there is a market for all of us.
Well, excellent. Thank you very much indeed, and best of luck. Thank you.
Thank you.
The next company to present is Gomspace, and Gomspace works with global tracking, Internet of Things, communications, defense, and security, remote sensing, and science missions. So now please give a warm hand to the CEO, Niels Bruus. Here you go, Niels.
Thank you very much for having me here. I would like to give you the latest version of our adventures in the space. Let's move on. My name is Niels Bruus. I am the first chairman of the company when it was founded 15 years ago, and I've been the CEO since 2014. So that's also quite some years now. We have the CFO as well, Troels. He's not here today, but Troels Dalsgaard, he was also in the company that a long time ago, and he was participating in when we got listed here at the Nasdaq. The chairman of the company is Jens Målø. He's got a lot of experience from the space and defense industry in Denmark. He's the chairman of Grundfos. And the previous chairman, I know you're not operating with vice chairman here in Sweden, but we are. That's Jukka Pertola, a Finnish guy. He's a top 10 board member in Denmark. The company was founded in 2007 and out of the university in Aalborg. And as I said, we were listed in 16 up here. Today we are around 200 employees. We are growing quite a bit, and it's going upwards, and there's a lot to do all the time. We have a long track record with many missions, many products sold to other people's missions, and so forth. We were the first company to deliver nanosatellites for ESA, the European Space Agency. As it says here, our core competence in these small satellites is radio technology, which makes them the satellites very useful. We have a lot of very interesting customers all around the world, all parts of the world we can export to, because there's obviously a lot of sensitive technology that makes it not possible to export to some countries. Last year, we had a turnover of 214 million Swedish, and we have right now an order backlog at 540 million Swedish kronor. The guidance for next year is something between 264 and nearly 300 million. It will all depend on how quickly we can get employees into the company. The trip that we are putting the company on now is, and we are announcing step by step new parts of a strategy, is that today we are the technology leader within nanosatellites. But to exploit the opportunities in the market, we are building towards larger constellations and standardizing the product range, and eventually looking into how to deliver services to our customers as well on an infrastructure service basis. Okay, the market is growing very, very rapidly. This year, the market size is about 420 billion US dollars. In 2030, it's expected to be more than a trillion, up to 1.4 trillion. That includes services, but also manufacturing. Okay, we are part of the biggest growing part of the space market, except for OneWeb and Elon Musk SpaceX, which drives a larger part of the satellite market. Our area is by far what's it called, a good growing market. Our technology is affordable. It's affordable for companies, but it's also affordable for countries. And that means that today there's about 100 countries that have space programs. We're working, for example, with Colombia at the moment, teaching them and building up their space capacities. It's illegal opal mining. That's a big problem in Colombia, and you can see that from very small satellites. Okay. The journey that we are going on now is that, as I said, we are a technology leader. We are growing the market now, or growing our business with more and more projects. But when we get projects into the company, we need many engineers. The next phase that we are going into is standardizing so that we are having more products in our portfolio. That means also that we can, or it means two things. It means that we can grow our business quicker, we can scale quicker, but we can also make more money on it than we do today. We can grow the market with now, but we are not as profitable as we would like to do. The next step is to scale up production. We are getting closer and closer to large constellations, and scaling up the production will again make it possible for us to grow the earnings, but also scale the company on that. And eventually, our aim is to be able to deliver the satellite platforms for other people to put instruments on a service basis. We can see that many of our customers have larger cost of capital than we would have in that situation. So we're driving towards that in our longer term planning at the moment. We are located in headquarters is in Denmark. The head office, you could say, is here in Sweden because we are listed here, but we also have a subsidiary here that makes propulsion for nanosatellites. And then we are in Luxembourg. The Luxembourg government have supported space a lot, so that means that we are building up the facilities there. And by the start of this month, we have also started in Toulouse in France, and will build up a presence there. We can get good engineers in that area. That's the reason for being there. Then we have a sales office in the United States, where we can sell to commercial customers. We are not positioned yet to sell to defense customers, but we will build up our European presence first before we will take a bigger step to go to the US. We have a beautiful headquarters in Aalborg, very close to the university. We have all the facilities for producing, developing, and so forth. We what we are doing is that we are making all the satellites, we're developing the parts of the satellites, we're putting the satellites together and making them what's it called, a total product. Then on top of that, we can make the radio payloads. That means the radio technology that can sense what's happening on the ground, or they can communicate to or from the ground and to other satellites. And then we can put it together in total constellations for our customers, meaning that we can control the satellites from the ground. We can help them getting all the licenses. We can help them getting all the launches and so forth. So it's a turnkey solution that we can provide to our customers. The market is driven by digitalization. I think all of you have heard that for many years, that that's the case. But that has also reached space now, and the space solutions can play a part in this, because it can potentially be done at a very low cost compared to terrestrial systems or fiber systems. One case study is that we are making satellites now for air traffic management. We were the first ones with that satellite you can see here to show that it is possible to track aircrafts over remote areas, high seas and things like that. At the moment, we are making 3 very, very advanced satellites for Indra and Enira in Spain. They are the top 3 air traffic management companies in the world. And for that, we will be able to make air traffic management, a solution for air traffic management, everywhere on the face of the Earth. That means that an aircraft like the MH370 will never disappear without you know where it happened. Or you would have more distress signals coming back at an earlier time. But it's also giving enormously savings. When you have the aircrafts going over the Atlantic, for example, they are flying in corridors, and they're flying with a long distance between each other, and in the corridors and between each other, because they are on their own when they're out there. With this system, you can have the VHF connectivity with them anywhere on the Earth, and you know exactly where they are. It means you can place them closer, and it means that you can save a lot of energy with this. So this is a very, very interesting business case that have taken new developments with the Indra order that we have with them. And with this, we are really on track to develop the company from a technology company to a more product-oriented company, and eventually to a service company. Every time we take these steps in the company, we open up a larger addressable market. For technologies, the addressable market is about $1 billion. For constellations, it's about $4 billion annually. For services, it's about $10 billion revenue potential or total addressable market for us. So that's very interesting, and the earnings go up accordingly to that as well. So that's a trip that we are putting the company into now over the next years. And just some financial at the end of my presentation here is that we have been able to drive the growth in the technology phase, and we are also on the back of a big, what do you say? We had a big crisis because we lost a big customer at some point. You can see the numbers there; they were very bad. But we survived that, and we have put the company in a completely new situation and be able to work positively into the future. The order backlog is very good. We are having a very good response for everything that we do for our customers. So that's a very good situation as well. The shareholder structure, for those who don't know, we have about 10, 15,000 small shareholders, and the biggest one is 10%, and the next is 3 and 2% after that. So it's very much spread out as it is. To give a what's it called highlight, we are a pioneer in this area, and we are now positioned to be able to capture the large growth for the future. The outlook for us is very good because we have a very good order book, and we also have a very good reception for our products in the market. We are positioned to scale up with constellations. We have the first order coming closer and closer to us now. And we are the strongest with regards to technology at the moment in our segment. And we have a very, very strong track record for the company. So with these words, maybe a little bit quicker than intended, but I hope it gave a good overview for where we are and what we are doing. Okay.
Well, thank you very much, Nils Boos. Question about the satellite industry. Yeah. Is there a risk of overcrowding in space? How well regulated is this field of business?
There's a lot of space up there.
That we know.
But if you look at how it was with the pollution of the sea for 30 years ago, you said it's no problem. And you didn't do anything. And today we have a big problem that's very, very difficult to solve. I think it's the same that's going to happen in space. If we do not make sure that we are more careful now, we will have very, very big problems in the future. So what is important is that whenever a satellite is sent up, that there's a mechanism to take it out of orbit again once it's not being used. So at least it's only those that are being used that's up there. The other thing with regulation is difficult because there's no specific owner. Every country have to be in agreement to what to do. So it's UN treaties that's put into what's it called, legislation in every country, and not everyone is following that. And it's very slow to have this regulation. But we don't see that there is something that's holding the business back at the moment. The biggest challenge is radio frequencies. That is to have the right to send and receive from space. That's the biggest challenge for the business. I foresee that there will be space traffic control like air traffic control. That's an absolutely necessity for the future.
Nils, in terms of aviation, you mentioned the energy savings perspective. Yeah. Could you please elaborate a little bit on that? Maybe I was not the only one who didn't quite understand the energy savings perspective in that transition.
When you fly from here to, I think there's one for San Francisco, here from Stockholm, isn't there? When you fly there, you cannot fly the optimum route because there's many. Yeah, it's the routing because there's many aircraft in the air, so they have to. But if you can place them closer, you don't have to take a detour as otherwise. And also the timing getting into the airport, so you don't have to circulate over the before you can get in. You can plan at the long distance because you know exactly where the aircraft is.
And I assume there is a safety aspect added too.
Yes.
Well, thank you very much, Nils Boos. Yeah. Thank you.
Thank you.
The next company is Metacon. And Metacon develops and manufactures energy systems for the production of hydrogen, heat, and also electricity. And with us today we have CEO Christer Wikner. Please give him a warm hand.
Thank you very much for having Metacon here today. I will try in the following few minutes to guide you through an introduction to Metacon, to tell you a little bit about how we see the market for hydrogen, and in particular green hydrogen, which is our focus market. I also want to describe our product offering and solutions, how we intend to go to market over the next couple of years with really transforming our company into a commercial company in green hydrogen. Also try to describe a little bit about where we are going, how we see the future plan. So Metacon is a technology company. It's been around for quite a few years, waiting for hydrogen to happen, basically. And I think all of you are seeing more and more of hydrogen right now. In fact, we see an explosion in green hydrogen coming, and I'll show a little bit more about that. We have a mix of products and solutions. We have an in-house technology with patented solutions for reforming of various other types of gases to hydrogen. But we also added sort of the mainstream technology for producing green hydrogen today, electrolyzers, in parallel to this. So we now have a complete offer, you could say, to go out and meet these growing market needs in hydrogen. We also want to partner in this space because we see much more growing and many more opportunities than actually what the world can provide solutions for. So we are a highly partnering company, you could say. So why are we so excited about green hydrogen? What's really triggering us every day? Well, we feel that we have a very important and fun and probably extremely profitable role to play in supporting these needs. We have winning solutions in transportation. Hydrogen hasn't exploded yet in Sweden, but in many other places of the world in transportation, you're starting to see that we are discovering hydrogen as a really strong option. We can actually, with hydrogen, behave in exactly the same way as we always behaved in transportation. We drive long ranges, we go to the gas station and refuel in 3 minutes. We have no problem in the winter with cold. So companies and people could actually just continue as we always did, refueling with a 100% pure fuel. And that's what excites us a lot. We are turning gray industries green. And you see this, of course, in the northern part of Sweden with the steel industry. But there are many other examples. I mean, in fertilizers, for example, we have deep sea shipping, we heard about before. Very exciting areas for us. And on top of this, all the trends that escalated over the last couple of weeks, of course, with energy independence and our wish to be more self-sustainable when it comes to energy. Our products and solutions also support this in a very good way. And therefore we are committed to building a company that can get all these products and solutions to market. And we feel that there is both a huge business opportunity, but we also have a very important role for our societies and for the world to bring this to market. And what are we going to sell, at least in the initial phases? Well, we have a mix of products and solutions. At the top, you see our product range for combined heat and power. You could see it as a heat pan for real estate or for buildings where you, instead of using the electricity grid, you use different types of gas. And out comes heat, electricity for your building, or we're working also adding cooling to this, because you know if you can produce heat, you can also produce cooling. So, and then based on the same technology, we have a scaled up version actually producing large amount of hydrogen from various types of sources. We have electrolyzers through partners, and electrolyzers you all heard about because it's It's a mainstream technology for producing green hydrogen today. Of course, you need green electricity to be able to do that. And we very recently also took a step more concretely, so to say, into the hydrogen refueling station market. Because hydrogen refueling stations are strongly linked to developing the transportation sector for hydrogen. And we can feed hydrogen refueling stations with green hydrogen from either electrolyzers or from reforming, for example, reforming of biogas. So, and we are in a, you could say, a pre-commercial phase. We obviously sold some, we placed systems here and there, we have tested a lot of our technologies, but we are standing in front of a much more interesting phase for the company right now. And we have a real position already in several countries with people representing us, as you see to the left here. And we have a lot of focus on Germany right now, because Germany is a super interesting market, both when it comes to the energy transition, of course, and they have a very, very big biogas sector that we can address. So how do we see the market? Well, there are, as we see it, 5 growth drivers here. One is the extreme situation, you could say, when it comes to the political dimension right now. I don't need to describe to you what's happening. You see it every day, announcements about energy independence. We also have a very, very good tool in green hydrogen, not because it's new, but because hydrogen has been used and are used since long massively in the industry. And that means that if we can make that hydrogen green, you suddenly transform an industry just by making hydrogen green, as you see in steel, for example. There has been a lot of binding targets already in place, all these national targets for when we should be carbon neutral, etc. You have seen this in many, that's a sort of a framework for us. We have growing investments in infrastructure. Even in Sweden, you see pipeline projects right now, and you see hydrogen refueling station plans spreading. And then, of course, massive sort of efforts to bring down the cost for green hydrogen. And that is, all of this is happening at the same time as a basis for us, and we feel we are perfectly positioned to participate and support this development. Our focus is on Europe right now. Longer term, we can go global. But Europe is actually taking the lead for many reasons in this transition, which is very, very good for us. And we started a daughter company in Germany because Germany is such an interesting market for us. So we will have a special focus on Germany over the next few years and hopefully beyond. The market, well, you have seen this, we also heard it mentioned before, some of the big things happening in hydrogen and in green transition. We know that the hybrid project got a lot of attention. They will need a lot of green hydrogen. At the same time, H2 Green Steel, similar type of project, but starting from scratch. They also need a lot of green hydrogen. Interestingly here, you see the numbers here. This is about 2.5 gigawatts of electrolyzer capacity. The total global production capacity for green hydrogen through electrolyzers today is probably around 5 gigawatts or something. I saw Nel announced very recently that they are scaling up their production capacity to 0.5 gigawatt with a future potential to go to 2 gigawatts. So already these two projects are consuming a large part of the world supply capacity for green hydrogen. And then you see these types of announcements, big consortia forming all over the world which is really massively bigger than what we hear up in the north. So there is really no way of today seeing how can the green hydrogen world sort of supply at the same pace as these efforts are being started. Well, everybody is coming together in a very special way. Politicians, companies, public organizations, investors to support this. It's going to be extremely interesting to see what happens in this area. Moving over to our offer, what are we going to offer to this market? Well, first of all, we are addressing certain needs in the energy sector with more specialized products. So this product is actually not a production unit for green hydrogen. This is actually a heat pan, you could say, an electricity unit for a building or a telecom station, for example. And we are utilizing our internal technology here to take gas from different sources. It could be natural gas or LPG. Obviously, we are pushing biogas, because if we are using biogas, we get a more green solution. And out comes electricity and heat. The same core technology we are scaling up to be able to produce hydrogen from different sources than electricity. And this is really, really interesting, because as you know today, there is a lot of talk about access to our green electricity. And there's going to be a little bit of a battle over the green electricity. We provide a different route, an alternative route to green hydrogen, and that is through biogas. And that's where we see a lot of our focus moving forward. Electrolyzers, we have built a business area in electrolyzers, but that's not an in-house technology area. We provide sales engineering, we provide expertise, solutions knowledge. We find the customers, we take the deals where we can, where they are reasonably sized. And then we work with partners. And like I mentioned before, we have added HRS, or hydrogen refueling stations. And this fits very nicely with our overall portfolio. This is also together with external suppliers and partners. So, and here's an example of that. We have a strong partnering group together with GISAB, now owned by Järnbro, one of Sweden's biggest service companies and engineering companies. GISAB built the first hybrid electrolyzer in Luleå and are providing maintenance for that. So they are really on top of this. They are a super good partner for this. Wherever we can, we work with GISAB in our quotations and projects moving forward. Peric, the world's biggest supplier of electrolyzer, been around for many years, several installations in Europe, pioneering installations in Europe since a long time ago, and ABB for all the electronics. Continuing on the offering, you can see that we have sort of 4 basic areas, product areas, and we feel we have identified very clear target customers, target markets for this. For example, for the CHP unit, we see small companies in Germany, car dealers, pharmacies, these types of companies who want to be independent from the grid. They hate rising electricity prices, and they hate a fluctuating electricity grid. So they want to have a more stable supply to their facilities. Similar sort of case, of course, for telecom, where we hope to be able to tailor-make this solution to fit in telecom stations for gas sort of drive instead of electricity dependence. The hydrogen reformers, where what we call the HHG series, is heavily focusing right now on the biogas market, and I'll describe a little bit more about that. But also, we have methane or biogas produced from all the world's wastewater plants. And here we have hundreds of thousands of wastewater plants where methane is a greenhouse gas about 100 times. You see different numbers, but up to 100 times more warming of the atmosphere than carbon dioxide. So there's every molecule of methane or biogas that we take care of has a 100-fold impact on the climate. So this is actually a climate cooling activity to take care of methane and convert it to hydrogen. And of course, the marine area is also very interesting. We have projects in the marine area, and we heard about it before. Electrolyzers very much focus on the transportation sector for supporting all the refueling stations, but also, of course, the industrial projects. I also talked about the HRS sector a little bit, but here is very interesting that also in Sweden we see now a lot of projects. We are moving from like a handful of refueling possibilities for us today to, over the next years, probably up to 50. And then you have a completely different situation. Then you could dare to buy a hydrogen car because you know you can get around. It's like when battery electric cars started, you didn't really know if you could buy one because how am I getting around? That is changing. Here is the case for biogas. And we can look directly on the chart to the bottom left here. We see that for a German biogas plant, today you are making a profit by producing electricity of about 350,000 euros. If you produce fuel for buses, it's less. If you instead start producing hydrogen, and you have two different cases there. One, if you burden the biogas with an alternative cost, but you still make more money from producing green hydrogen. And if you take the free biogas, the one you're flaming away, a lot of these plants are just flaming away their biogas, then there is a very, very interesting business case for these biogas owners to move into the green hydrogen space. And this is what we want to address now moving forward. So coming a little bit over to our plan moving forward, how we intend to grow. We believe there are three core areas for us and where we are investing and where we want to really build the company strongly to meet these needs. One is to finish our product development, also to absorb new innovative projects that come our way because we can provide solutions. One is, for example, a project we announced recently where we can take ethanol, convert it to green hydrogen, and provide high power battery electric charging off-grid. These types of really mind-blowing activities is what's driving us. But we have focused now on our core products. We want to invest in manufacturing, and we are really oriented towards a breakthrough effort now in Germany, but after that, to step-by-step increase sales in other places. We have different flows where some money going to come from. Basically, we have different sources. Main focus is on the system sales, but we also have a big service business, and we have a leasing possibility for this. We won't do so much licensing because we are careful with our in-house core technology right now, but we could do that. So in summary, we have a strong momentum. We see the market growing, really exploding right now, and probably will do moving forward. We have a political situation really moving our way, pushing things in our direction. We have this wish to become decentralized. We don't want to have a big central production that is sensitive to whatever, war or terrorism or things like that. And we want to have leverage of our strong pipeline of innovations and new opportunities. This is something we're going to push. And then I hope to get the last bullet here. It's everything we are doing is based on our unique portfolio of technologies, both in-house and very, very strong partnerships. So we are very, very excited about taking the next step now with the company, a company that has been around for several years, waiting for this to happen. And we feel we are building the structure now to really go out and make big business on this. So thank you very much.
Well, thank you very much, Christer. Of course, I have a few questions for you. On March 4th, you presented the news of PERC, the refueling stations in Europe. How important is this for your business case and your development in terms of the fueling stations?
Well, refueling stations as such, of course, is important. That is key to the transportation sector developing green hydrogen. So, and then there are many actors in this space, and we could work with different partners. But we have been working with PERC in the electrolyzer area. It's working very well. They think like us. They are very proven. So we see them as an important partner for us.
Excellent. So in terms of the future, you've shown very well here your plans. But if you look 5 years ahead, where are you then?
5 years ahead, we are a much bigger company in mature commercial phase, selling in still mainly in Europe, but also in other parts of the world.
Primarily other parts of the world, as in?
In North America, as in South America.
Well, excellent.
Probably also in some Asian countries, yes.
Well, it will be very interesting to follow your further progress. Thank you very much, Christer Wig.
Thank you very much. Thank you.
The next speaker we have met already in the panel. He represents Envigas. And Envigas build, own, and operate high-precision, large-scale pyrolysis processes to turn organic residuals into commodities sold to a range of applications. So again, Lars-Gunnar Almryd, CEO of Envigas, welcome up on stage.
Fossil-free steel. You have all heard about it. And you have all heard about, most probably, that hydrogen is the solution to reach fossil-free steel. But is it enough? And is it true? To reach 100% fossil-free, no. Then you need carbon atoms. And those carbon atoms need to come from the biomass, as we see it today. I will tell you in this presentation more about the steel industry transformation regarding this, how a big-scale production capacity of biocarbon needs to be built in order to meet this demand, and how we at Envigas will contribute to this development. Let's start. No? The Swedish iron and steel industry accounts for more than 10%, exactly I think it's 13-14% of all carbon emissions in the country. If you take the industrial output, it's around 40% of the industry's CO2 emissions, using millions of tons of fossil coal annually. This can be replaced by hydrogen together with biocarbon to make 100% fossil-free steel. But you also need to change the technology. Because if you stay with the old blast furnace technology, it will not happen because you can't change the total need of fossil coal with biocarbon in the blast furnace, maybe up to 20%. So biocarbon is the enabler for 100% fossil-free steel. And Swedish biocarbon produced from forest residues can replace the imported fossil coal. And Envigas, through our high-temperature pyrolysis process, can do this and produce this biocarbon in combination with other value-added streams coming from the process. Some words about the steel production in European Union in order to put us in the right perspective. As you see in this slide, we are in Sweden and Finland together counting for approximately 7–8% of the steel production in Europe, which makes us relatively small in a European perspective. But if you look at the iron ore deliveries from Sweden, we count for 80%. And if you know the ambitions with hybrid, for instance, a lot of the development in this transformation will happen out in the Nordic countries, which makes this extremely interesting. No? In 2022, around 9 million tons of steel is expected to be produced, and there are huge investments planned. If you take the existing steel industry, 65 billion of investments are planned in order to produce fossil-free steel. This is in the existing structure. And if you look at the need of biocarbon for this, if you want to make it 100% fossil-free, all of it, you have a minimum requirement of 350,000 tons of biocarbon. If you add to this the plans that H2 Green Steel has, that you have on the bottom of this slide, you see that they aim to produce 5 million tons of steel, and they will invest something in the region of 25 billion for this. And then the need for biocarbon will increase even more. So you see, it's a huge industry that needs to be built up for this. Some words about the raw material and some fundamentals in this that is important to understand, because sometimes these discussions go wrong about what we should use the forest for and so on, especially in these days. If you look at the left of this picture, you see a tree. The bottom of the tree is used basically for sawn timber. The mid of the tree is used for pulpwood to produce pulp and paper. The top of the tree is normally used for energy purposes, producing bioenergy. If you look at the details of the bottom part of this, the sawn timber, you can see on the right side of the slide, you see how you cut the logs in the sawmill, and there you can see that you get approximately 50% of the tree you get as planks and boards, and you get approximately 10% of what you put in as sawdust. And the sawdust that goes to the top of this cycle for the bioenergy, for instance, for producing pellets and so on. And then you also produce wood chips from the sawmill that can be added into the pulp and paper part. If you listen to the debate sometimes today, the same people who want to keep the trees in the forest, they also say that we should build more from wood, because that is a good carbon sink. And it's better than steel and concrete. But this is like in the slaughterhouse. You can't just take out the fillet. So if you want to build in wood, you will also get the other parts of the tree, because you can't just take down the bottom part. And this is often missed in this. And the point in this slide is that there is, since many years, a good utilization of the tree usage, I would say. But this needs to be refined even more. And if you take the top part here, which also consists, as said, of residues from the bottom part of the tree, the bioenergy part also needs to be, I would say, more transformed into biorefineries, where you also take out valuable materials and products out of this. You don't just make energy out of it. And that's the whole key of this, to utilize the tree and each part of the tree in the best way. We, as Envigas, we are the first Nordic large-scale producer of biocarbon. We have an experienced team I will come back to. We are privately owned by founders, financial and industrial investors, and employees. We have approximately invested 200 million into the processes and facilities we have today. And we have owners, among others, Consejo Invest, Bayer Ventures, Filian, and Imran Capital, among the biggest. Our concept is to build, own, and operate our plants. And we are replacing fossil alternatives with fossil input with renewable alternatives. We have a plant in Skellefteå I will come back to, and we have a plan for scaling up. And we're also working with value-added streams out of these processes, which I also will come back to. We have a committed and experienced team as we see it to execute this. All is about people at the end. On top you see the key team to execute the steps we have in front of us, consisting of a big variety of origins, you could say, or nationalities, and a relatively high educational background. We have 4 PhDs in relevant areas for what we're doing, and the rest is also master and bachelor science level. So the average level is good, but also combined with good and relevant experience in the areas where we're working, both what we're doing, but also the applications at customer site. We have a board of directors that is also very experienced from industrial background, financing background, developing companies, and so. We have representatives here if you want to talk during lunch or breaks with the chairman, P.O. Vedin. And we have Martin Gemvik and Tobias Brink here as well, who are working with the business development mainly. This is our Swiss knife. That's the production process and the technology we use. The core of this is the pyrolysis process, where you heat up without adding oxygen. You heat up the biomass from 20 degrees to 600 degrees. This is the core of the process. Whatever you have around it, you always have that. Here we have illustrated that we start with wet biomass. You can start with dry biomass. So on the left-hand side you have the heater. Out of the biomass you produce a solid phase, the biocarbon. Approximately 25% of the material put in you get out as biocarbon, approximately 40% of the energy content. The rest goes with the gas. Today, in our factory in Skellefteå, we produce bio-oil, pyrolysis oil, which can be used as a raw material for fuel production. But you could also use it for, in the simplest way, for heat purposes, but you could also use it for electricity generation, the energy content of the gas. But then, as you see in the right-hand bottom part here, you can also treat the gas and refine it and split it, so to say, to take out the essential values of it, which is hydrogen, it's CO2, you could produce methane. But in this, we are working more on an R&D scale, and we have some steps to be taken before we are fully there, but the opportunities are there. So it's a bit where you establish and how you want to build it, how you utilize this Swiss knife. Our large-scale proof of concept facility in Skellefteå, where we established in 2017 a test plant, which we have been using in order to learn technology, but also to qualify the products at the customer, which is an intensive work because no one has done this in this scale before. And it has been a lot of development going on together with the customers for the last years in order to qualify the products before scaling up. We have also installed our full-scale production plant in operation since some time. That has a capacity of 5,000 tons per year. So it's big in a historical scale, but small in a future scale. For this, we have a plan of how to scale up in order to be relevant for the customer needs. And this is a little bit how to deploy the Swiss knife. This map illustrates not firm places which is decided to establish at, but it's for you to illustrate for you and for you to kind of see the combinations needed in order to get efficient processes. Because you need to take into consideration logistics and where you are if you have raw material, but you also have to find locations where you can make an efficient process and utilize existing infrastructures that, for instance, to take care of the heat, because you will have a lot of excess heat from this process, and it's an advantage if you can utilize that in an existing system. You might find a place where you have an existing turbine, for instance, a boiler. Your capex goes down, but you might need to do it together with someone. So it's these kind of concepts you need to find and also develop how to utilize the Swiss knife in the specific localization. And these are three examples. If you establish, for instance, in the Örebro region, you have a lot of pellet mills, and you also have pulp and paper mills, you have CHP plants, and so on that you could utilize. If you establish in Luleå or Boden, it's quite clear you have customers close, and those customers might also need the gas in order for their process to work. So that could be an interesting combination together with the biocarbon, which makes this biocombinate very profitable. In Norrköping, for instance, you have a lot of pulp and paper industry, which makes it interesting. what I didn't mention also, which is interesting to take into consideration in this map when we talk about using the tree and the wood, is that we can also use recycled wood. So basically, we could also use the planks when they have been used in a house for 70 years. So that's an additional opportunity. And that you have to take into consideration also when choosing your place, because the recycled wood is most probably where people are and where you have residual or recycled wood. The expansion could potentially take place in 3 steps. We could potentially have a first plant in operation in 2025. That would be a plant based on, as simple as possible, I would say, technology based on that the simpler, the easier to get it up in scale, because it's a huge scaling that needs to take place. The next plant, we could go for a more maybe refined also solutions and upgraded solutions for the gas and so. And on the third one, even more. And then I think we could also extract more values by then out of the biocarbon streams, also on the path to, for instance, graphite and similar products. So, as a summary, and what I have tried to tell you, biocarbon is an enabler and a necessity for 100% fossil-free steel production. The Nordic addressable market is around 350,000 tons in 2026, and that has a value of approximately 2.8 billion SEK, and a rapid expansion of biocarbon production capacity is needed to meet this demand. Envigas plans to scale up with relevant capacity of biocarbon production in combination with value-added products to meet other needs in combination with this. Thank you.
Well, thank you very much, Gunnar. You talked earlier on in the panel about the scarcity of biomass, and there was talk about that there is no scarcity. But in terms of streams of materials, waste streams, for instance, you mentioned the recycled wood. What do you foresee in terms of being able to increase the supply of biomaterials that would enhance your production?
I think you have a big potential in utilizing the recycled material. You also, like we're working with in our test plant to test new raw materials, I think there will be a future in agricultural residues, for instance. So there will be new streams, but there is R&D needed for it. But otherwise, I think it's about using the sources we have smarter. If you take, for instance, now we have the sawdust where we produce wood pellets. That's a way of densifying and making it more, so to say, transportable and so. And then you use that to burn it. If you instead use it to produce biocarbon, and then you take care of this residual heat, you get much more value out of that. And you can still utilize the heat. Okay, in the heat balance you might need to put in some more pellets, but it's a much smarter utilization of the material that we already have.
So there is room for improvement here.
Yeah.
Competition. Would you like to mention anything about what if you have competitors?
I think it would be excellent if we had more competitors, because what is needed in this huge scale-up that we are seeing is that you need to get, I mean, everybody needs redundancy in terms of suppliers, and that goes for all parts of this chain. So the more competition and the more actors in this, the more relevant it will become to develop and refine technologies for the scale-up, and so in all steps. So I think we need as much different solutions as possible.
Excellent. Well, thank you very much, Lars Gunnar Almryd, and best of luck. Thank you. Now we all need to refuel, right? We need to eat lunch. So let's meet back again here at 1:45. And those of you do not stay in behind your computers or lunch, make sure you refuel too and move about a bit so you have new energy when you come back. All right. Please take your seats and get ready for the second half of this exciting day here at Grand Hotel in Stockholm. And welcome back, all of you watching us, following us online. Organoclick is the next company to present. And Organoclick was founded as a spin-off from research at Stockholm University and also from the Swedish University of Agricultural Sciences already in 2006. And now it's a fast-growing green chemical company with a vision of a world free from plastic waste and free from chemical pollution. And with us here we have the CEO Mårten Hellberg. Give him a warm hand.
Great to be here. My name is Mårten Hellberg. I'm CEO and co-founder of Organoclick. So nice to be in front of an audience again after having looked into a camera for 2 years. So really nice and really fun to be here. Well, as was presented, I met 2 Swedish professors 16 years ago. They had already in the mid-90s started to understand that this would become a problem. Plastic waste and petrochemicals that have been the traditional way of producing chemistry and materials since the mid-19th century. They started to see that this will be a problem. Today, about 8 million tons of plastic are released into the ocean every year. And what they were looking at was, are there things in nature that you can use to replace these plastics and petrochemicals? This is a field of science called biomimicry. We're looking at natural chemical processes like what is the chemistry behind a tree becoming so strong, or why does some leaves become water repellent, or why does some trees burn less good than other trees? What are the natural molecules that is creating this type of properties in plants and trees? From this research, and when we started the company, we really had a strong mission. We wanted to replace plastics and toxic chemicals with bio-based solutions. And when I met these 2 professors, they had developed a technology which we call modification of cellulosic fibers. That is, we can click on different bio-based molecules to cellulose, which are the base in paper, in textiles, in wood, and click on molecules that gives new properties. Depending on what we click on, we can get properties like water repellents, fire retardants, durability to rot fungus, or improved strength. And we use technology called organocatalysis. This is a chemical process where we use small molecules derived from fruits or derived from different plants. And this organocatalysis was actually awarded the Nobel Prize last year. And we can say that we're pretty proud that Organoclick was one of the first companies in the world to start using organocatalysis in commercial applications. And now, 16 years after we started the company, this was awarded the Nobel Prize. From this research that we started 16 years ago, we have developed a number of different products and different product areas where we use this core technology. We have a way of treating wood in order to give it fire retardants and improved durability, where we replace biocides and heavy metals used in traditional impregnation. We have another area which we call biocomposites and biobinders, where we use natural biopolymers that replace plastic polymers in non-woven and technical textile materials. So we're replacing plastic binders. That is the way of creating, for example, a napkin that you can find in restaurants. They are made of cellulosic fibers and plastic polymers today. I'll talk more about that later, but this is something that we are replacing. And finally, we are making textile waterproof or water repellent by replacing fluorocarbons or PFAS molecules, which is now about to be banned in the European Union. This has been they are hormone disruptive and cancerogenic, and this is something that one have realized during the last 10 years, and now they are being banned, and we have a technology to replace them with biodegradable molecules. Today then, 16 years later, we are we are a growing chemical technology company. We have our headquarters and our production facility and R&D lab up in northern Täby, Arning Industriområde, if someone of you know where it is. There we have 5,000 square meters with a production capacity of 10,000 tons per year. Now we are upgrading it. We have invested in a new production line, so we will double the capacity to 20,000 tons of our chemistry per year. And last year we had revenues of 110 million SEK. So been growing steadily during the last 10 years since we launched our first product in 2012. Our business is organized into 4 different business areas. We have the functional wood area, where we are targeting the wood industry and the building industry. We have what we call the green coating and maintenance area, where the textile impregnation product is located. And then we have the biocomposites and non-woven and technical textiles, where we are targeting industrial companies like non-woven producers, specialty paper producers, and technical textile producers. We have developed 4 different technologies that we can use on all different materials: water repellents, mechanical strength, fire retardants, and rot protection. So this is let's say the red line of the technology is the cellulosic fiber, and that we can use our different technologies on the materials where cellulosic is a natural component. Yeah, this is an example of our customers that we are working with today. The first area, non-woven and technical textiles and biocomposites, are, as I mentioned, targeting industrial customers. Duni was an agreement signed with last year, and there we are about now to replace the plastic binders that they are using in their napkins and in their tablecloths with our bio-based binder solutions. Just 1 month ago, we announced the new collaboration with Ahlström-Munksjö, where they are also producing specialty paper and non-woven, and they are now about to replace also plastic binders in their different products with our bio-based binders. Sharpcell is another Finnish non-woven producer. Baux are producing sound-absorbing panels that are used on walls, and they are using them biofibers, which we are binding together with our binders. And Fredal Rydéns is Nordic's largest producer of burial coffins. They are also using our binders in their material to bind the cellulosic fiber together in their coffins. So quite broad range of different customer groups, but we are using the same type of product from us, the same technology, to bind fibers together in these areas. Within the functional wood and the green coatings and maintenance area, we are mainly targeting resellers because these are more consumer-based products, but also professional users. But we are strong in targeting the building industry and working with most of the building suppliers in Sweden, also growing a lot in other parts of Europe. And for Organoclick, we've been growing extremely well during the last year, and are now included in most sport retailers in Sweden, and are also growing a lot in Norway, Finland, the Netherlands, and Denmark. If we go into what has happened during the last year in our industrial area, we signed a contract with Duni, which is worth approximately 30 million crowns per year when we have scaled it up to full scale, which is expected to happen in the second half of this year. So this is something that we are ramping up right now together with them. In February, we signed a deal with Ahlström-Munksjö, which is then we are now coming into agricultural textiles. So this type of textiles that you are putting out on fields, but also in their customer Ellepot, they are making flower or plant pots. That is this type of material that you use around plants that you put into the ground, and this is for industrial growth. So this is an area which is quite big actually, and this is a reasonably big customer of Ahlström-Munksjö. We have also 10 customer projects in production test, about 10 different customers, and these are among the 20 biggest producers of nonwoven and specialty papers in the world. 2 of them are close in also being new products launched, so hopefully we can go out with some more news regarding that shortly. And in order to grow this segment, we have now also invested in a new production line which will have a capacity of 10,000 tons per year. And this is being built up right now, and we plan to take it in operations in Q2. Within the green coatings and maintenance area, we have then, this is a consumer brand, so this is used for re-impregnation. It's like an aftermarket for textile impregnation. Here we have sold, this first product was launched in 2018. Last year we also launched a shoe care program. We're here replacing the traditional way of making textiles waterproof, which is by this PFAS and fluorocarbons. And here we've been growing very well during the last year. We more than doubled the revenues in this product segment last year. We signed the new reseller agreements with XXL, Stadium and Herx, adding about 200 more resellers. And for that expansion, we invested in a new production line for filling bottles, because this is really the biggest part in production, filling all the bottles, because we're shipping out thousands and thousands of these bottles all the time. And this was also the biggest problem for us last year, if I go into the problematic part, because this filling line became late. The delivery was late due to the COVID factory that was affected by COVID. So we had to stand and fill all these bottles for the new customers manually. So we had to take in half an army of people to fill bottles last year. And that was very costly for us. But now that is solved, that problem. Within the functional wood area, we are now launching a new generation technology that is replacing the old technology. This is something, this is really to be able to compete even more against traditional pressure impregnated wood. Technology which have a lot better durability compared with the old technology, and also easier maintenance. Here we also signed an agreement with Base Timber UK to expand our business into UK. This is now being ramped up during Q1 and Q2. And the German market, which we were entering 2 years ago, grew really, really well. So this is also what we are focusing on a lot, to continue the growth in Germany. If you look at economic development, this is a picture which have 2 sides really. We have been growing steadily every year for the last 5 years, as you can see. We were actually growing a little bit better last year, but, and this is the big but, we had two major problems last year. First of all, raw material prices. They were increasing heavily last year. We had some of our raw materials were increased in price with more than 100% during 1 year. And this affected our gross margin, as you can see here on the line for gross margins a lot. We have had a positive trend for gross margins during 4 years, and we expected this to continue because we are changing the product mix. But due to the fact that raw material prices increased so much, we were always like 1 quarter after to increase prices to our customers. So it's been like one of the major things we did last year was increasing prices to customers all the time, because we got new price increases from our raw material suppliers every quarter. And that fact, and also the fact that this production line became late, so we had to use a lot of manual labor to produce the bottles, made that the EBITDA, which we expected to be positive last year, if you look at the trend, it was very close to being positive. It actually decreased. So, and this is what feels really good. In Q4, we were finally back on track with the gross margins again. We had been pushing up prices every quarter, and then when the prices started to level out during the autumn, we could get back on track. So we increased the gross margins in Q4 compared with Q4 2020. Which felt really good, because we have been worse every quarter, in particularly during Q2 and Q3. So now we feel that we are in a good position. All prices have gone up, as you can see with the inflation, of course. I mean, we see that because we are buying in raw materials like molecules, and that is where the whole inflation starts, actually. Just to mention an example, which is a small part of the inflation for food, but citric acid, which is a component that we use quite a lot, increased with 300% last year. And that is the main component for creating this type of taste, which is a little bit sour in all foods as well. And that was a 300% price increase. And we use that quite a lot in our products as well. So this is the reality when you're looking at raw materials from really this small component side. So I said in June, we will have a big inflation in food prices coming up because we saw all these small molecules going up in price heavily. But now, finally, we are back on track here, and that feels very good. Looking at the outlook of 2022, we expect Organotech to continue its fast sales growth. We see very good sales here in the beginning of 2022. So here we don't see that this will level out at all, the sales increase that we have here. This is also very good for us because this is one of the products where we have good, above average profitability. So this is something that is driving up our gross margins for the whole group. One of the key things that we're working on, of course, is ramping up the production to Duni and to Ahlström and Munksjö. But also finalizing the two most advanced projects that we have that are in late stage. They are all of these projects are in the same level as the Duni deal. So this is the same type of approximately the same type of amount that we can sign on these deals. And this is, of course, when you see this deal that you signed with Duni, it's a 5-year agreement, so it's long-term deals that you sign with this type of companies because they want to have stability in their supplies as well. For the functional wood segment, we are switching over to the new technology. This is a very important thing for us. We will phase out our old technology and phase in the new technology, but also continue with the international expansion, in particular in Germany and the UK. The UK is completely virgin market for us. We have a good distributor agreement there with Base Timber UK, which is have a good sales company. This will be really interesting to see where that leads. And of course, this new production capacity that we're adding, that is an extremely important thing for us in order to grow further. Because one factory which we are working towards, like the Duni factory, they are using in amount of between 2,000 to 4,000 tons per year of binder. So it's quite large amounts that we need to produce and sell to these customers. So in order to add more customers, we need to add more production capacity. We also believe that the product mix and also the price adjustments that we have made during the last year will now start to make the gross margin grow again, like it did in Q4. So we expect that to continue now during this year. And we now also have a plan, and we believe this will work to keep the OPEX at a steady level from Q4 last year. So all this included will, of course, create much better profitability. This is the goal for us during this year. So with that, I thank you very much for listening.
So, Morten, there is much awareness now about the PFAS that you talked about, the hormone-disturbing chemicals that are in lots of products. And, for instance, there are in food containers.
Yes.
So how about the possibility, and would you look at the prospects of moving into the segment of replacing, for instance, fast food, well, the hamburger packages, some of them have those hormone-disturbing substances. Yeah. It's a huge market.
Absolutely, and here I then want to talk about our collaboration with Pulpac that we announced last year. Pulpac is very innovative, or now also fast-growing company making 3D-shaped packages or machines for 3D pressed packages, which is called dry molder technology. And they are working, for example, together with OF packaging, so AR packaging, and other packaging companies. And there we are using our technology to just replace PFAS for food packaging barriers. So we are involved in that field as well.
Excellent news. Who wants to? We don't want to eat out of packages that are a threat to our health, right? You mentioned the Nobel Prize that is behind this innovation. How about competition and other companies using these innovative techniques?
I have to then look into the various segments. I think where we have the least competition is within the bio-based binders for non-woven and for specialty papers. There we are completely alone in offering 100% biodegradable and bio-based binder solution for non-wovens. And this we get confirmed from all customers that we're working with. No one else is doing what you're doing. You seem to have been very early in this. And yes, this is the truth. We started developing this already in 2008.
Way before the Nobel Prize.
Yeah.
Excellent. So the next step, next big step for you this year, you mentioned that you were sort of you estimate that you're over the hump with the challenge here with that you just pointed out. So what are you looking forward to the most during 2022?
Ramping up supply of our binders and looking at also the continuous development of organotex, which is also doing very well right now.
Well, best of luck, and thank you for coming. The next company is Cortus Energy, and Cortus Energy has developed a solution for replacing fossil fuels with a solution based on existing technologies. The technologies are combined with a groundbreaking approach of gasifying biomass into a fully integrated process. So with us here we have Rolf Ljunggren, Vice President. Here you go. Warm hand.
Yeah. Thank you so much. It's a pleasure being here, presenting a little bit of what we are doing in gasification of biomass and renewable energy. And this is a picture from our plant down in Höganäs in the southern part of Sweden. It's a 6 megawatt plant we have built in this place, and it's actually from where our business will go further. A little bit about our company, the project in Höganäs, and then where to go from here. So it's this company is 15 years old, will be 16 by the end of this year. Started in a small scale testing in a lab scaling KTH here in Stockholm. Doing first tests, feasibility test in 150 kilowatt scale in 2009, building first gasifier 2011, making that into an integrated plant over the next coming years. Then we came down to Höganäs, and that's a cooperation within the Swedish Iron and Steel Society, and starting that project in 2016. And building the plant, taking it into operations. This plant is for substituting natural gas in reheating furnaces in this steel plant. And what we see forward is the hydrogen side of things with the project in France, power both in the US and France. Then we see synthetic natural gas here in Europe. We have for more hydrogen projects in Germany, in Japan. We see a change actually in hydrogen to make hydrogen transportable and distributed. There is an interest in methanol as a carrier for hydrogen. Projects in many places. And then, of course, we are working with a steel company. The question of steel industry is how to go green And then it's, of course, to eliminate the use of carbon or mineral coke in their processes. So we are a company of today, 33 people, half of it in Höganäs and half of it us in Kista here outside Stockholm. The process is really the new thing about making more value from biomass. And what we have done is to divide the process in three steps, doing drying, pyrolysis, and high temperature gasification in steam atmosphere. And what happens is actually that we get a very clean gas out of this. We actually have 60% hydrogen in this, and that makes our gas unique when it comes to gasification from biomass. Thing about it is that we use the heat efficiently, so the gasifier being fired at 1100 degrees, we use the rest heat from that to heat the pyrolysis at 400 degrees, and after that the dryer at 100 degrees. So in such a way we can be energy efficient and resource efficient, meaning that about 80% of the energy that is within the biomass comes out in the product in the end, in the energy gas. So we can do this from different biomasses. The feedstock we see is rather flexible. So it can be from wood, it can be from crops, it can be industrial waste material, or mixes of this. We have a portfolio of patents for the gasification process as such, for green hydrogen, the special reactor we have, how we get our carbon product and steam into it, and also coking of biomass, and doing this for steel industry. We also have a liquid process which we tested during 2021 together with the Swedish Research Institute and a Danish catalytic company, Haldor Topsoe. So what is this? Well, it's about the energy situation, about bridging the gap from low-grade biomass to the industry and transport requirements in a larger scale. And we do this with this, as we say, ultra-clean syngas. And as you see, it's more or less hydrogen with carbon monoxide and a little bit of methane within. We see a very good potential. These times are testing for all of us, but you all know that the energy market here in Europe has been very volatile. And if we look upon that, the opportunity for the biomass gasification is really the best we ever seen. The biomass cost is of course going up, as so do all energy sources, but not in a similar way to fossil. The high energy prices in the EU, both for natural gas and electricity, gives us actually a positive incentive for green energy towards the fossil. The high prices for CO2 emissions, it helps too, so that's good for us. And we have also seen a switch that the industry being more focused on getting to know technology, but now there are projects going on in as we said, steel industry, but also in the chemical industry, which actually we haven't seen for many years. The green transport fuels is an obvious one, and with the price, especially here in Sweden, Germany as well, it's really a good incentive for green fuels. So with the Höganäs project, where we are today, it's really a plant, 6 megawatt, meaning about 2,000 normal cubic meters of gas per hour. We have a 20-year offtake agreement with Höganäs for the product. We have built, we own, and we operate the plant. The CO2 reduction from this installation is about 10,000 tons per year. There is an expansion possibility both for gas and for the carbon product. Höganäs is, well, in Sweden, well-known company, but it's a major, if not the biggest, powder metallurgy company in the world. For the project in Höganäs, we also had some partners like SSAB, ABB, Outokumpu, Sveaskog and Södra for fuel, financing from Energimyndigheten and Klimatklivet to Swedish Energy Agency and Swedish Environmental Protection Agency. Also Calderus for the installation of the high temperature gasifier. The results from this is we have seen the full syngas quality produced from the start in this, and we have this quality verified by third parties during 2021. We have tested this in Höganäs furnaces, and it works as specified. We still have some technical issues on char dusting in the pyrolysis, the mid step of the process, and we need to come a little bit longer with that. We have some modifications we have done for capacity, and we continue with the operational tests forward in 2022. 3, with the biomass, there are lots of different ways forward, and we are also working with different ways. But the main stem upwards is, of course, the gasification with the syngas produced, where we add a catalytic upgrade on the left-hand side. And there it means we can do liquid fuels, we can do alcohols, biogas, or any other chemical product. The good thing here is that is well-known technology. It's on the market, has been there for, well, decades. So it's really the thing is to have the gas that we can produce. Then you open up for all of these applications. The other side is, of course, on the right-hand side, the hydrogen. And hydrogen is a very hot topic for being a clean energy and being a clean energy of the future. And you can say it's not only its energy abilities, it's also as a raw material when it comes to chemical production. And there it's really a big commodity. So the need for green hydrogen is really essential. And you can also say that when the alternative today is mostly to use electricity to produce hydrogen, we can actually provide hydrogen to a very cost efficiently compared to electricity, and especially with the electricity prices right now. So what we see in this way forward is really the gaseous fuels, it's the liquid fuels, and it's also the solid, the carbon product, the biocoke. And this makes our technology platform unique. So when we look upon the hydrogen pipeline, we see two specific ways forward. One is the hydrogen for road transports, and we see that on the maritime side, it has changed from gaseous hydrogen to methanol being more of an interest because it's so much easier to handle, and having a vessel at sea with a high pressurized flammable gas system aboard is not that attractive. So we see that as the way forward. When it comes to the carbon product and steel industry, we actually we actually see this. This looks a little bit like charcoal, but it's not. It's a little bit more efficient when it comes to handling in high temperatures. The steel industry here has a big issue, and the way of solving that is, of course, to find a green source of that needed carbon. We have been working with that together with Höganäs and within the Swedish Iron and Steel Society for more than 5 years now. So it's a very fascinating thing. When we look forward, we see the opportunity for green methanol. It's been a tremendous interest in this direction, and as you see, not only here in Europe but out in the world. Green natural gas with the catastrophic development in Ukraine and so on. The Russian gas for Europe doesn't seem to be sustainable. It will be gone by 2030, it's said. And what will come instead? There must be an alternative. There must be an energy source. And we think that our synthetic natural gas is the best option for that. When it comes to power, it's obvious that there is a difference in the power market where you have intermittent type of renewable electricity coming from windmills, coming from solar power that needs to be complemented with a base load kind of power where the biomass powered solution will be very important for that development. When it's green hydrogen, I think one could say that it's a hype, more or less. You can say it's really a strong demand for several type of applications. We see that as a very good opportunity. We see that when it comes to the long-term possibility of cost-efficient sourcing of green hydrogen, the biomass-based solution from us is a very attractive solution. There is also the possibility to co-produce hydrogen and green CO2, which we have been involved in a project in France for, and we will see what will happen on that side the coming year. The last part, the green carbon for steel, it's really a large demand when it comes to these type of industries, and the sourcing of biomass will of course be a very important part of how do we use our resources in the best of ways when we go forward. So we see these opportunities, we work with them, and this is our way forward. So thank you very much.
Well, thank you very much, Rolf, you again. I have a question about competition. Of course, this is a huge market, and we need a massive amount of players. But if you look at, from your perspective, your outlook on competition, please.
Yeah, I would say when it comes to different applications in this, there are some special companies, niche companies, who have technology for one of these, not like for the carbon production, for some type of liquids. When it comes to the high quality gases, I think we are still ahead in the market, and we don't see that obvious competition in that area.
How about regulations? I mean, what we see now coming out of, well, as a result of the war that's going on, it's a high pressure on renewable energy.
Yeah.
What is your take on the need and the possibility for regulations in enhancing this transformation?
I think it will be very strong, because I think a country like Germany don't want to rely on their society's welfare on some despot in East. That will not happen. So I think the drive for this, both from, I would say, the consumer perspective, but also from the regulation perspective, will be very strong.
Well, thank you very much, Rolf Ljunggren. Thank you.
Okay.
The next company is Ecoclime, and Ecoclime's business case is optimal indoor quality, air quality, and more sustainable energy consumption. And with us we have CEO Marcus Sandlund. Warm hand to Marcus Sandlund.
Thank you. Thank you very much. My name is Marcus Sandlund. I'm CEO of Ecoclime Group since 1st of March this year, so it's quite new in this position. So it's my first presentation since I started. We are in the change connected to the global challenge, as we all know about. And by 2025, buildings are projected to be the largest emitters of greenhouse gas on our planet. And we're on a mission to change that. So our vision is zero emission buildings. We want to help the property industry and the real estate industry to lower the climate impact. We future-proof and increase the value of properties. We help property owners to create profitable and climate-neutral buildings by offering world-leading technologies, solutions, and services in the broad spectrum. For that, we have our 3 business areas: smart buildings, circular energy, and indoor climate. In our business area smart buildings, we had the IoT hardware and the cloud-based platform, so we interconnect all systems in the building, so we know how the building and the real estate will perform. For that, we can also add smart lighting systems and smart recharging systems of vehicles. In our business area circular energy, we recirculate the energy from primarily waste energies, like wastewater. So we can recirculate the wastewater up to 20 times and have a high efficiency of our reuse of energy. Our 3rd business area is indoor climate. There we can create one of the world's best indoor climates, which is draft-free and soundless distribution of both heat and cold. So with these 3 business areas combined, we can provide the technologies for a better future for real estate business. So our 4 ways of doing this is we can take care of the waste energies in buildings. Up to 1/3 of the energy one-third of the energy that we have in the building is wastewater energy, and we can use that up to 95% and reuse it in the building for heat and heat water production. And therefore, and the last step is to improve the comfort for those who lives in the buildings and the residentials who are there. And we can also have, as I said earlier, the charging techniques and the lighting techniques. So our formula for success is high impact, profitable, and high quality. Meanwhile, we are creating value for our customers, our shareholders, and the climates. That's the 3 pillars for Ecoclime. And how could we have high impact? If we install an Evertherm re-energy system in a building, in this example, we can show that we can recycle 95% of the wastewater energy to provide the building with reused energy. We lower the CO2 equivalents with 13.1 tons a year, and the property owner saves 26.6 kilowatts per square meters a year. So that's high impact of the building performance. And why we say it's profitable. You have an ROE on an investment in this Evertherm system of 168%, and you have also better cash flows from the buildings on the building's total lifetime. What's high quality for us? We guarantee the performance. If you align us with a service agreement when you purchase a system from us, we can guarantee 90% efficiency of reused energy in the wastewater. We have a long-lasting system that are maintenance-free, and we, as a group, are present throughout the whole value chain. And that makes us quite unique. We have the project development and our own R&D area. We manufacturing our own components in our own fabric in Vilhelmina. We have our own sales organization, our own design organization, and we also do the project services for our clients. And for those clients who want, we can also offering financial solutions. Because we are in the whole value chain, we are a very stable partner for energized automation of a building. What drives the market? We have a rapidly growing market, and it's in the news all the days about the crisis in Ukraine connected to the energy crisis for Europe. We already had Fit for 55 and the European Green Deal and the taxonomy coming from the European Union. And now they're also talking about repower the EU. We see the environmental trends, we see the regulatory trends, economical, and the transition to more sustainable. And we also must optimize the usage of energy. And that's are the trends that are driving our market. We can also create economical, social, environmental value for a better future by interconnect our business with 7 of UN's global goals. We are directly linked to these 7, and that makes the business model more sustainable for us and for our clients. And the numbers, we just quite recently presented our communique for 2021, and we had almost the same turnover as last year, and we had a little lower EBITDA cost for investments we are doing our continuous growth. We ended the last year by purchasing or did an acquisition with Miljöbelysning, so it will increase our turnover for 2022. So 2021, what was drove our growth? We have new products and new solutions we put to the market. We increased the delivery capacity for our fabrics in Vilhelmina so we can produce more systems. So we are now in the phase of scaling up the production in Vilhelmina from 50 to 450 system deliveries a year in the start of 2024. Indoor climate are increasing the sales through sales partners. Circular energy has rapidly grown during the year. We have launched a geothermal business called Team Westman. We are incorporated in our business area Circular Energy. 2 of 3 business areas delivered on target EBITDA now. And we had a new management on place, where I'm one of them, but we also recruited new CFO, new CSO, and new CFO, and we started this year with the acquisition of Miljöbelysning. And how we will continue? We will continue to grow through our core products, we will continue to grow through our organic growth, and we will continue to grow through our acquisitions. We have some analysis on us, and the most analysis we have are pointing that we are in the right market, we are in the right place, and we have the ability for further growth. We are now working with the best and the biggest property companies and building and construction companies in Sweden, and we also established cooperation in, example, Germany. So we have done projects for SBB, Peab, Bostaden i Umeå. We are now looking on a project with Victoriahem, etc. And it makes us strong. We are putting these systems into real properties now, and we can measure the data, how the system perform, and we can continue to develop our systems to even get better. Repower EU, it's now one of the biggest drivers for us. How should we solve the energy problem in Europe while lowering the gas consumptions? So heat pumps is one really big possibility for creating energy closer to the properties, and our system are a heat pump system to extract the energy from the wastewater. So we say that reuse and recirculate energy with re-energy systems. We don't need to produce all new energy. This energy we already have, and we can use it yet again and again in the buildings, and therefore make the buildings more energy performance better. So, summary of this short presentation. We future-proof and increase the value of properties. We have high impact, profitable, and high quality. We want to create value for customers, our shareholders, and the climate. Ecoclime helps to solve the global climate challenge by reducing and recycle the energy in real estate. We have world-leading technologies and solutions and services. This is sizable for us, and we are in a growing market driven by megatrends. And we also have the continuous strategy for continued growth. So that's what Ecoclime are. Thank you.
Well, thank you very much, Marcus Sandlund. In terms of markets, we have a tradition, a background here in Scandinavia of being, well, we have been quite good at energy efficiency in terms of buildings. We're fairly good, at least, yes, compared to many other countries, such as, for instance, the former eastern parts of Europe. I just recently had a conversation with Heimstaden's chief of sustainability, and they're moving into Czechia, for instance, Czechia, and what's going on there in terms of real estate and energy efficiency is massive.
Yes.
And it needs to be massive. So what markets do you think are the most promising in terms of your products and your techniques?
For right now, the most optimal market is Sweden, actually, because we have the systems so we can interconnect easier with, but we are seeing the big change in the mindset in the whole of Europe. Now, when gas is going out, they need to replace it with something else. So the whole European market is really interesting, but for now, Zenit is in Sweden.
So you had some plans in Germany. What is going on with those plans in Germany?
Yeah, we are investigating now with partners how we can combine our systems to their heat systems, because every country has different systems how to handle heat and how the contracts are looking to tenants and property owners, and we must connect to the business model so we can create the business models who are good for every part.
So there's a momentum still in Germany.
Yes.
Absolutely. Well, excellent. Well, thank you so much for clarifying that, and thank you so much for your presentation.
Thank you.
Well, we need a break again. So let's meet back again at 2:05. There is coffee served here at Grand Hotel, and take care and shake about a little bit, those of you watching us online. Welcome back. We have 3 more companies to present. So those of you present here at Grand Hotel, please take your seats. And the next company is Ferroamp. And Ferroamp's Energy Hub Systems introduces a new way to integrate solar power, energy storage, and DC loads into one system. And with us here we have Krista Werner, CEO. A warm hand to Krista Werner.
Very much. Thank you. Thank you very much, everybody. It's really nice to be here. And it's nice to see all of you here again and actually be on a physical meeting. I have really longed for having that chance. I will, over the coming 15 minutes, give you a glimpse of a fantastic Swedish green tech company, fast growing with a great opportunity. But I will start in the end to ask you all in this room if you have figured or if you have thought about getting an electric vehicle. Has anybody in here thought of getting an electric vehicle or already bought an electric vehicle? Good to see, good to see. You're not alone, I could tell you. There is a lot of electric vehicles out there now, bought and on our road. What's the most common question among people buying an electric vehicle? Reach, where do I charge? Do I have enough capacity to do that? Will I do it at home, or could I go to my parents-in-law and charge at their place? Because the prices for electricity now is going sky high, extremely expensive. I would say that among my friends and where I'm talking, everybody is more or less talking about an electric vehicle. And they're also talking about how and where do I charge this electric vehicle. It means that you need to take control over your electrification. Everything we are doing now at the moment is about getting more electrified. And I would say over the last terrible weeks in the world, I would say that this will even maybe put higher demands and requirements on the electrification going forward. If you look into the statistics on Bil Sweden in Sweden, I would say that I just read it the other day that 52% approximately of all cars sold in January, February this year was electric in some way. More than 25% was pure electric. This is only talking about the personal vehicle, but if you also add on all the other vehicles around us in the society, the last mile transportation, as well as the public transportation in front, buses, etc. It's a huge challenge for our society going forward to handle the electrification. This means that a lot of us is thinking about taking control over our electricity, our renewable energy. We are adding on solar energy on our buildings. We are adding on wind, other renewable energy sources into our system. This puts also a lot of requirements on the system. A facility owner today are facing a lot of challenges that they didn't do just a few years back in time. They need to take control over their electricity. They need to handle the cost for the renewable energy into their facilities. They need to handle the fact that it will be even more crucial for the tenant and for the customers to the facility to have access to electricity and electric power when they need it. They need to make sure that the facility is future-proofed so that they could add on and build out when they need or if the need will expand over time. They need to be able to make sure that we could continue investing in our facilities so that we could go forward and expanding and also giving our customers the opportunity. To do this and to take control of the electrification, you need to get data. You need to get knowledge about your facility's consumption and production of electric power and electric energy. You need to be a prosumer. You need to both produce as well as consume. And one good thing which many European countries is talking about now is to make sure that we could handle sharing of energy and energy power out in the nodes on the grid, because the grid itself would take too long time to build out, so that we need to make sure the facility owners, facilities out on the nodes could share electricity. Therefore, there are new rules that has been introduced in Sweden and Netherlands and other European countries also to make sure that it's possible to share energy out in the nodes. And this is where Ferroamp comes into play, this fantastic Swedish company. We are a fast-growing clean tech company offering a possibility for facility owner to take control over their electrification. For the facilities, different facilities like homes, real estates and industries. And the core of our system solution is the Energy Hub. It's a patent solution. You can see a picture of a small version going into a villa, a small villa. It's a patent technology, but it also offers a possibility to connect the grid in the facility with all the production and the consumption of electric energy in the facility. It also is a connected device, so it gives you the opportunity to have high resolution, real-time data to control and monitor your need. We have a scalable product offering. 4 different type of buildings. As I said, this is a small version for a villa. It could be scaled up to a much larger facility. It could be built out over time, so you could start your investment in your facility in a certain amount, and then you could scale over time. I said we are a fast-growing company. Our first invoice to customer was sent approximately 2016-17. We have, over the last years, grown. Last year, we ended up in 110 million SEK in turnover. We left 2021 with a record big order book, and the order intake for 2021 growth with more than 120%. And the good thing here is that we have now proven our technology by having 3,400 installations of systems out in customer premises and facilities in Sweden. Most of these are in Sweden, some are in Norway, a few in Netherlands and some other places just for testing. But it's proven, it's up and running, it's supporting and giving 3,400 facilities electricity control. As I said, the company is more than 10 years old. We started 2010, the first patent was granted 2013. And the first customer invoice was sent 2017. We are moving from a pure hardware company into a solution customer offering customers a service solution, including both a hardware portfolio, making ability to control, but also a software portfolio. We have over last years outsourced our production, meaning that we now are scaling up our ability to serve the market in much higher volume than we had before. Up to last year, we produced everything ourselves in Spånga, just outside Stockholm. Now we have 3 large partners that will also support us in industrialization, cost reduction program, and handling the really challenging component situation on the world market. I said 3,400 system. We are now increasing our market presence rapidly, and we have a scalable solution and a stable solution that is now certified for future or further expansion. So as I said, it starts with the Energy Hub, connected the facility to the net, also giving the opportunity to connect all the production and consumption in the facility, the energy storage, the EV charger, and other loads and producers in the facility. But it also gives the opportunity for different facilities to connect with each other and share, for example, an investment in energy storage or PV power. And on top of this, we have the energy management system, the high-resolution data generated regarding both production and consumption. So this is a glimpse of our product portfolio. The Energy Hub, we have a range of different type of energy storage, different sizes. We have the solar string optimizer, connecting solar power to this to the energy hub and to the house. And at the top, we have a cloud-based energy management system. And it's where actually here the magic happens. This system gives the opportunity for the facility owner to sort of move electric energy both in time and space. And what do I mean by that? It means that you could take charge over when and how you are using your electric capacity. You could choose to charge your electric vehicle, coming back to the first question, very fast if you want to, but also you could choose to charge it when it's as cheap as possible. Or you could, using PowerShare, connect with a neighbor and share your PV production to your neighbor's need, if so. And this is a really, I would say, important thing going forward in the electrification, to be able to handle the peaks in power in the facilities. This is the really bottlenecks going forward, to be able to control the peaks that you have in your capacity need. This is just a glimpse of the PowerShare. For example, there could be a local area with different houses that has different patterns in usage, different needs over time, and that are placed in better, or during time, better position when it comes to PV production. We have a couple of installations where we, for example, have some houses are better production on PV power when the usage is in other buildings, so they could share between each other. We have in this picture small villas, larger real estates, and an industry that has different patterns over the day and could share this energy between each other. This is also actually a patented solution that Ferroamp has. We have, Tesla has the patent for this in Northern America, and we have the remaining world. So we think this is a very crucial thing for us going forward, to be ability to make sure that not only controlling within the facility, but also between facilities. So all in all, we are facing a market with some really strong market drivers. There we are changing from facilities being pure dumb consumers of electric energy into giving the real estate and facilities the opportunity to take control over their electrification. Meanwhile, we are expanding the use of electric energy. We also give a possibility to explore new business models for a facility owner, to make sure that we could meet the different needs of the different consumers in the building, as well as connecting different type of renewable energy sources. So the nodes goes from being dumb consumers into smart prosumers in the new electric system. We give the customer groups, both business to business as well as business to consumer and EV charging owners, the ability to take control, to monitor, and to handle their electrification. We give them high resolution data that they could integrate with other type of systems, giving a possibility to handle their way forward. We're also giving them the possibility to be future-proofed in that matter, that they could scale their system over time, as well as having the opportunity to add on new producers and consumers over time. Coming back to our system, it's future-proofed. It's gradually possible to build out. It minimizes the investment cost, and by that I mean that the investment cost in different type of hardware solution is minimized. You could start up with one system, and then you could gradually build out. If you have started up with an energy hub system in your house, you could always add on both PV power, scale up the PV power, energy storage, EV charging, and get access to that. And you get help in the measurement of the data, in how to do this in a cost-effective way. We are using the direct current technology, DC technology, that is giving the opportunity to control the electricity much better, but it also gives less conversion losses. all of this creature that is in the system now, like PV power, wind, energy storage, as well as electric vehicles, are DC animals, as we say. They are run with DC, so if we could handle everything on the DC side, we don't need to convert between AC and DC. We just do it once when we do this. We have a couple of patents. One is the most important patent is the phase balancing patent. So, Ferroamp as a company, we have grown rapidly. We are now well positioned with a scalable product offering. We are moving from being a hardware-only selling company into system solutions company. We are selling the opportunity and the possibility for a facility owner to take control over the electrification in a world that is rapidly changing into a new, different way of handling with a large different way of customer needs. It's a modular, scalable platform. You could, as a facility owner, scale over time your platform and invest over time. On top of that, we have an cloud-based energy as a service platform with high-resolution data in real time. We have a proven technology on a proven business model. It's a scalable business model that we could expand going forward. We have future-proof installations. We have more than 3,400 installations, and we have a rapid growth. We are now ready to take the company to the next level and scale this business going forward. That was all I had today. So thank you very much for listening, and I guess there are some questions.
Yes, there is, Christer. My first question is in terms of circularity and end of life, yes, and replacing. What can you tell us about your take in terms of circularity? There is, of course, always this topic that needs to be addressed.
Absolutely. You mean in circularity in form of our taking care of?
Exactly, as in your products when they need to be repaired, replaced, in terms of battery replacement, etc.
We have, as it is today, building out a circular model of taking care of the full life cycle of our products. We are focusing on a sustainable chain of activities over that period. So that will be handled over time. That is one part that we have been building out of this. Yep.
Excellent.
And we are working going forward with partners taking care of a lot of this. So the different type of modules we have will also be in focus for.
You mentioned Spånga and that you have moved into other ways of manufacturing. Where do you manufacture now?
We manufacture on 3 different locations, mainly in the world. 2 of those are in Sweden. The 3rd is in China. We are, of course, continuously evaluating that the Chinese location was chosen before. I could say the world changes a little bit, but we have that on our radar in continuously evaluating that. 2 locations in Sweden. I say that we are going for a supply chain that will be close to where we are operating for the moment.
So a final question: if you were an average homeowner, the cost, just an estimate, and return on investment. If you want to purchase an entire system like you presented here, roughly in return of investment for a family?
Yeah, it differs a lot, of course, but it depends on your need and what you add on. But the return on investment for example, on the pure Ferroamp products is quite rapidly. It's going from a little bit of a larger facility within less than a year, if you're a villa, that you will have a return on investment on a couple of years' time on that.
That's quick.
Yeah, that's quick.
Well, excellent. Thank you very much for joining us today.
Thank you very much.
SaltX Technology, very exciting company to be presenting next here. It's a Swedish renewable tech company that has set out to solve the problems of renewable energy supply, demand, and also timing. And with us we have Carl-Johan Linné, CEO. A warm hand to Carl-Johan.
It's the third time I'm here now, standing on this place, and it's always nice to be here, Katarina, in those fantastic room facilities as we have here. I'm going to talk a little bit about SaltX Technology, and we are, and I should get one of those things also, so I can move the pictures ahead. We are a company-based company in Stockholm here, and we are developing an energy storages. And energy storage is certainly an increasing demand of it. Once we go more and more into renewable energy, we need more energy storages also. And we have a mission, as we have heard all the other companies do have here also, and we have a mission that we are going to make it possible to convert into fossil-free energy sources. And if we do that, we all know that if we come up to a certain level of renewable energy, more than 50–60%, the demand of storages is increasing rapidly, because as we all know, we cannot control the sun, we cannot control the wind. So we have been around for some years, and we have the base technical platform is actually a material that is called, we call it nano-coated salt. And it's a patent that we have, patent families, a number of them that are covering this. It's a special recipe that with the calcium hydroxide salt, we are making a nano-coating to prevent agglomeration of this energy transferring. We are certainly in a range where we can say that there is a big demand of the storages, and we will make it, we are on our way to make it possible to make the transition toward a fossil-free and decarbonized world. I start with the latest news from us, and this is, once you look on this picture here, you may recall that we talked a lot about the material development in the past. We had this innovation about the material, but along the road we took the decision to go more into a function orientation, a solution of the complete functions, because we thought we find out that we had to do it ourselves, because the salt was actually depending on the reactor that is charging the salt, and the reactor is depending on the salt. So we had to see it as one function. And what we are doing now, the progress at the Stockholm pilot plant, that's in Vattenfall premises in Bollmora, south of Stockholm. It's a 200 kV charging reactor with a 100 kV discharging reactor, and a lot of some silos in between there, and subsystem also. This is actually a cooperation with an Australian company called Calix for the charging reactor. And for the discharging reactor, we work tightly with a Japanese owned but Finnish company, Sumitomo Foster Wheeler. And this is really, I think it's what it's all about also, that the new innovation, the new technology that I think we are standing for, in combination with a mature business that Sumitomo Foster Wheeler, I mean, they have been doing reactors for 150 years. And if you could combine them, we have a very much a winning concept. So this plant is actually, as we speak, we are making the first test rounds, and we are see how much we can decarbonize and how much we can carbonize the salt. And we also will see about what we call the round trip efficiency. But it looks very promising, and we will come back with the result as soon as we will have them, of course. Another thing is a collaboration with another mature company, is Alfa Laval, and we've been signing an agreement with them, as well as we did with ABB also in the past, to have the best product and the best competence to make our energy storage solution even more efficient
to make the best out of it. And this is very good now when we have this installation in Bollmora in Stockholm. We can go out there, we can make the test installations, and we can try it out. So Alfa Laval is very eager, and so are we, of course, to get this up and running. The third new latest thing from us that we recently sent out the press release about was that we actually have developed some sort of a charging reactor by ourselves. And this is a quite unique thing. If you think about, for 3 years ago when I stood here, I probably talked a lot about the material itself. Now the company has transferred into a much higher added value, so to say, and we are making the function. And the competence and the knowledge that we have now, we have transferred into a new charging reactor that could do higher temperature and a higher power output. And this is something that we have applied for the patent. We haven't got it yet, but we have applied for it. And we are very excited about this because this makes it possible to make our energy storage application even more efficient. What it's also all about is really that we have a unique solution here with this charging reactor, which could make it possible to electrify the industry. Ferroamp was talking about electrification here before me, and it's all about that a lot, that green steel, and you make all other things out there. By this innovation, by this reactor, we can electrify some of the industry that are working with a very, very high temperatures and very high output. This is way too early to say about, to tell you about any details about it, but we see that there is a good opportunity out there to do this. So time will tell. Once, maybe I'm here next time, we will see how it will look like then. But we are very excited about this. And once I look on this picture here, you see that we come from a pure material company into this function-oriented and complete solution. So it's a major step. Some milestones in our company. We went public 2016, and we built the first the EnerStore concept, energy storage. We call it EnerStore. Was actually birth 2017. 2019, we built the first installation in Berlin at Vattenfall premises. A 0.5 megawatt history with 10 megawatt hour capacity, and that was running 2020, end of 2020, and actually a little bit before that also, but it's actually, we used power and to heat it up, and we used heat to put out in the district heating in the Berlin area. Then the plan was actually that we should have changed the technology a bit on this plant, but then the COVID came along, and the factory was closed down totally in Berlin. So we said that we had to do something, and then we had the opportunity to start up to build this pilot plant in Stockholm. So we did that. So that is now up and running with the latest reactor technology. So we are getting prepared now for the pre-commercialization phase in our company. We talk to a number of customers that are interested in this, but we also have the knowledge and we need to actually to create the market in a way also. We had a competition in Helsinki Energy Challenge for some years ago that came in 255 applications, how to make Helsingfors as a carbon neutral and fossil-free city. And we were one of the 4 winners in this competition. So that also shows that the market is not market is getting prepared for energy storages, but they don't know exactly how and where and when it's going to be installed. So I've been, maybe I mentioned this in the beginning, but it's a peak shifting thing that we need to charge the battery in the electrical vehicle, as Ferroamp said, once the electricity is cheap. Then you want to take it out once it is expensive to levelize the cost of electricity, of course. And also, once you get up to the level of 40, 50, 60% renewable electricity in a country or in a market, you need about 1/5, 20% in energy storage capacity to cover up for the sun and to cover up for the wind. So that makes it, I mean, we have tried so many times to try to see how big is the market out there, but it's huge. Once we come to the stage where we have fossil-free sources, it's going to be a lot of energy storages out there. Not only our technology, there will be a number of other technologies also. But we offer a green, economical, and robust solution where we actually don't have any dangerous or any high pressure or anything that is special. It's pure natural material, the salt, and it's a lot of available on the market out there. Where do we then exist on the market if you make some sort of segmentation on the market? On the x-axis you see the energy capacity, how big is the battery, and on the y-axis you see the storage time. So since we have thermochemical storages, we can store the energy for a very long time without losing any energy, or we can also be flexible to have it more frequent. But we say that we are in the area of 10 megawatt hours, which is quite big. That's where we want to be. And that's why we need a big reactors also, as I mentioned in the beginning. and we say that we need to, the ideal situation is that we want to have between one day until 1 week storage time to be able to get the best business case out of this. Then we have the pumped hydro, which is on the very right-hand side, and the batteries. But the batteries here is lithium-ion battery. You cannot make energy storage with lithium-ion battery once you come up to this size as we are planning for. It's going to be not economically at all. We have 3 areas that we are looking into. We call it heat to heat, power to steam, power to power. And what we mean by that is that we heat to heat, we charge the salt with heat and we take out the heat. And then we have the alternative to heat the salt with power, electricity, renewable electricity, and we take out heat, and also power to power. What we are focusing on is clearly the power to steam area. We know that a lot of the market is talking about batteries, and then it's very often power to power. But 49, almost 50% of the energy demand in the world consists of steam. Steam for the production in the industry, but also steam for the remote heating and the district heating. So the common picture with people overall is that battery is power to power, lithium-ion battery, but the heat, the steam area is as important as the power is. A very important area and interesting area where we have a lot of talks with the end customer is actually the industry, where they are using today, they are using on the bottom of the picture you see today, they are using oil or coal as a fossil fuel, and they store it, oil, and then they are they're burning it once they need the steam in the production. So some of those customers actually have their own energy sources. They have wind or they have PV. So what they want to do now is they want to throw out the oil and put it in with an energy storage. It's called heat storage here in this picture, EnerStore. And you can actually take out the steam whenever you want. So renewable steam on demand. That's a very important sentence to remember. Renewable steam on demand. And that's going to be very, very important, especially in the industry side, and makes it a little bit easier also to replace the existing solution in the industry. How does it look like then? Well, this is could look like the Bollmora case doesn't look really like this, but it could in the future it will look like this, where you have a charging reactor. Today it's the Calix reactor built on a so to say falling bed technology. And then we have the discharging reactor based on a fluid as bed technology. And then we have the storage here. And the storage is actually charged salt and not charged charged salt. And talking about the capacity itself, it's actually depending on how big do you make those silos. The bigger, the higher capacity you will have. So it's actually also that flexible. So you can have one power in the charging and one other area in discharging. For instance, in Helsinki, Fors, the challenge was really they want a pretty slow charging over the summer month. And then they want, under a couple of weeks where they had a very cold temperature, they want to have a quick, powerful discharge. So the roadmap for commercialization is really that we are standing on the threshold now to make this pre-commercial. And what do I mean by pre-commercial? It's actually that we have proven the technology with our own pilots. We want the customer to be part of this pre-commercialization. And we have to build those installations. And then after that, we will go fully commercialized after that. Okay, that's about it. Thank you very much for your attention.
Well, thank you very much, Carl-Johan. Where will you be in 5 years, and what do you need to get there?
Yeah, that's a very interesting question. That keeps me awake also during the night sometimes. But I think with the new innovations that we have now, we see a lot of opportunities. I cannot say more than that at the moment, but we see a lot of opportunities. We see possibilities to install energy storage in a wider scale, but we are looking at the moment very much on this renewable energy on demand, steam on demand, where the industry we make it possible for the industry to convert to fossil-free sources. And here we are working very much in cooperation with ABB and some other companies to make this happen, because we have the same interest. We want to get rid of this oil and coal.
You mentioned that there is no shortage of your raw material, salt. But how about other components in your facilities? How are they affected by the situation in the world?
We have, I would say, we have very much under control, but there are certain electrical components that have a very long lead time certainly, and there we have tried to pre-order them even before we have the final design ready for the next, the bigger energy storage as we are planning to build. So we have taken a risk, maybe, to order this before we have the final design. But you're right, some components are lead time of 10 months, 12 months now, which used to be weeks before.
Well, best of luck with your work, and thank you for joining us.
Thank you very much for being here. Thank you.
Last but not least, Sens is next to present, and Sens develops projects in energy systems, and the company now has a focus on in large-scale sustainable energy solutions. And we will hear more now from Lisa Toll, CEO, a warm hand to Lisa Toll.
Thank you. So, hi everyone. Good to be here. Before starting my presentation about Sens, I will give you a very short explanation of who am I. I started as CEO for Sens in October last year. I've had my career within the wind energy business most of the time. I run my own company in the solar business and also invested at the same time in a startup called Pumped Hydro Storage. I have therefore been following this, or at least part of this company, as an investor the last few years. A lot of things happened in Sens last year. I was really thinking that the new strategy of the company really appealed to me. Being in the renewable energy business for 15 years, you really understand that the storage market is the next train that will run, and I want to be part of that. So therefore, I said yes to take the role as the CEO of this company and take it forward. So, Sens, like I mentioned, this company has made a huge turnaround last year. It has been in the energy business for over a decade, and it has a lot of experience from developing energy projects, from identifying to making the feasibility studies to construction, and then also being optimizing the actual assets. The energy technology that the company has been focusing on before has all been in terms of heating. So it's been heating, district heating and district cooling. The company, if you look at it closely, you will see that the figures from the last year's report are not so optimistic. So what the board decided to do was to say we need to make a drastic change here. We need to stop the part of the business that is not working well. But we do have something in this company that we really see a huge market for, and that's the knowledge of energy storage. The storage that was in this company was about storing heat. We also know that the storage of storing power in terms of electricity will also be a huge part of the future energy system, and therefore they decided to go hand in hand with a company called Pumped Hydro Storage, and that's Sens today. To ensure that this new Sens would be successful, a new management group was put in place to ensure the right experience was in the company to do this. This is what you've probably been hearing all day, and that's why we're all here. I mean, the world is really changing, and what we now see is the biggest transformation since the Industrial Revolution, and it has just started. And as was addressed here earlier, the last week's very sadly development in Europe is just making it even a more emphasis on how important it is to build more energy here in Europe. And what you hear is that the only the alternative, short term at least, is wind power. You know how we have the solar and wind power. That's the resources we can proceed with now within our part of the world. And there we see the demand for storage, as already we mentioned, is going to be huge. So, long duration energy storage, LDES. So I liked the interview, the presentation just before me. SaltX gave you a good landscape of all the storage technologies out there. I should have had one of those, so thanks for giving a bit of a preview on that. So we have two of those storage solutions within our company today. We have the need for moving the electricity to the hours where the sun is not shining or the wind is not blowing. And then we also have the storage for heat. That's a lot longer. We can store energy that is produced for summer. Pretend, for example, a waste-to-energy plant that has to produce also in summer because no one wants their waste to be lying there waiting until the winter. Today, all that energy is just taken out into the air because no one needs that energy in the Nordics, at least in summer. So what we can do is to store it. And then in the autumn, winter, that heat could then be used for the grid. So we have two kinds of storage within our company, and they are serving slightly different purposes. But the common thing here is that what we do is that we take the energy that is available, we store it until the demand is higher. I want to mention this because it's also get the question like, how large is this market? And I think no one knows, to be honest. That's why no one is giving a really good answer. What I've got informed by a report made by McKinsey on this long-duration energy storage, they are claiming that 10% of all energy in terms of electricity produced will be stored before used. So if you think of 10% of all the electricity that is produced in the world believed would be stored before use, then you realize that this is a market. And given that we're not really doing this at all that much today, there's going to be a huge demand out there. So, like I mentioned, we got two legs in this company. I will give you first an explanation about the first, what Sens brought into the company from before. And that's really all the development of sustainable energy projects connected to heating and cooling systems. So here we have a running business today. We are supporting our clients, which are most of all the energy companies that runs district heating and district cooling. Here we support them with making feasibility studies. A lot of these systems start to get fairly old. We also see new production possibilities, data halls and industries, and we want to make use of that energy into the district heating systems. And we are supporting them on the calculations and feasibility studies to enable this. Also, once all those assets are in operations, I mean, it's really important to ensure that we are now using data analysis to optimize the production and optimize the income. So we are doing that today. We also got patent in the company when it comes to this storage of that I mentioned, that you could store from summer to autumn and winter when demand is higher. So this is the running business. We will scale it up, but it's profitable today, and we plan to keep it profitable. The other leg is the other battery symbol. That's how we store electricity. So there are a lot of technologies out there. SaltX mentioned pumped hydro. Really, it's a proven technology. It's existed for over 50 years, I would say 100. It's quite basic, really. When the electricity is cheap and you have a lot of electricity available, you use that electricity to pump up water to a higher reservoir. And when the demand is higher and prices are rising, you let that water go again back to the other reservoir, creating hydropower. So it's not more rocket science than that. So it's efficient, and it's efficient for storing large amounts of energy. So that's how we, if you compare it to a battery, we are doing a large scale where you want to balance solar and wind power to the grid. However, I think there are one reason why this is not built in a large scale today. One of those reasons is that it's actually would be some environmental impact on the place where we want to build this. And I think this is what really, since I worked with development of wind power, of large wind powers, or wind farms, I realized that the permitting process is very long in these sort of projects. And this is what pumped hydro storage wanted to do, and what we at Sens are now doing. Instead of placing these pumped hydro storage assets up in an Alp lake or in the Swedish mountains, we are looking into how can depleted mines be turned into a pumped hydro storage asset. So when we are using something that is already been, humans have already been there, putting their impact on the environment, and now we are reusing that for a new purpose. Apart from the environmental impact that we don't have to do it in an alt lake, I think the other really good thing about using the mines instead is that if you look at it, the markets that would really have a huge need for balancing wind and solar would be the markets that does not have a lot of hydro today. And the countries that does not have hydro are typically flat in their nature, so it's hard to make a hydropower or pumped hydro storage if you're not finding a depleted mine that have the same prerequisites as the traditional pumped hydro. You do have the significant height difference, and you do have an upper reservoir and a lower reservoir. And this is what we're doing today. Our role here is to be a product developer. We could have been a consultant firm. However, if we look into the wind business, for example, we see that there's a larger share for us if we are owning the assets and sell them as an interesting investment opportunity rather than just bringing in our knowledge in this case. So what we are doing now, and what has started up last year, and what is really our focus at the moment, is to secure mines, as in ensuring we have long lease agreements with the mine owner that allows us to develop it into a pumped hydro storage asset, and we can sell that to the market as a renewable energy investment opportunity. I told you in the beginning, my background is from the wind energy business. So is the CFO in the company, and also other people in the company come from the wind business. So I think we all feel that we are understanding each other really well, and I think we're all seeing a lot of the ways things are being done in the wind business. That's the business model we are applying to our business. I often get the question then, when will this be profitable? I will, with this slide, try to illustrate how a developing company works in terms of that what we are doing is that we are eliminating the risks, and that is creating value. Long term, or short term, sorry, this is what we're doing. We're now ensuring we are securing the site. We are using our knowledge and our expertise to ensure we continue with the project that has the best prerequisites. We do see that there is already there an interest for investors to collaborate with us to take part of those projects, and I think that would be a realistic way of continuing how we work today. So that means we should not wait until one of these projects are being built before we can, gain profit from them. However, our long-term goal is really to instead have the asset as keeping it more to us and sell it later on. I mean, this is really the business model that we see that would be most profitable for us long-term. So, I told you we are focusing on this a lot at the moment, and we are on a few markets, mainly in Europe. We are also in South Africa. South Africa has got more than 90% from fossil fuels today. They have pointed out their energy system, where they want to go towards renewables, as one of their 4 key focus areas from the government. They have fantastic resources for solar and for wind, so they do need the storage in their future renewable system. And luckily, they do have more than 6,000 of depleted mines in the country. So we have an organization in place there that are now scouting these assets, looking through which ones of those that we think fulfills the right criteria, so we can bring them on to our portfolio. I can mention Sweden as well. We are focusing together with Veidekke, that has a lot of connections and relationships in this business in Sweden. So we're together now scanning also in the Scandinavian markets to see which mines would be the most profitable for us to proceed with. I'd like to mention this. This is being on the market that's not really there today. It's always challenging, but that's also, I think, most, what can I say, interesting bit of the work. We are now part of a council that formed last year. This council is really looking into worldwide what technologies out there are there to fulfill this need that we will have of long duration energy storage. And I mean, really, it's such a it's such a good thing for us that we can sit in the same small groups as, you know, Google and Microsoft, and they tell us what they want, and we are really part of shaping that market as well as developing our projects. I mentioned before we have a new management team in place. I've talked a lot about me. I'm also very happy to have Richard Tullberg in place. He's got experience both from banking and from the developing company called OX2. Martin Sjöberg is our COO, and he's got experience from both Vattenfall, McKinsey, and Skanska. So we really now a driven team that wants to ensure we take those projects forward. Also, the board was reshaped last year. Mainly, they made it smaller because we are now a fast-growing company on a new market. Important to have a smaller board to ensure we can have fast decisions. We have a new chair of the board, Mikael Odenberg, and he could really now support me and support the organization with the international connections he has within the grid and energy business. So, to summarize this presentation, like many other companies here, we see a mega trend. We see how we are now going towards electrification in the world, and really intensified the last few weeks in Europe. We see that to be able to have a stable grid with solar and wind, we also need storage. We have technology and experience from long duration energy storage of heat. We pumped hydro storage, building up a pipe of projects that we will ensure can contribute to stabilizing the grid in the future. So focus for me and the business in total is really to keep the profitability on the existing running business, and at the same time build up this portfolio so that we could take in investors that are interesting to join us there. Thank you.
Well, thank you very much, Lisa Toll. Question here in terms of competition. It's always interesting. I mean, there's room for many, I assume, but could you share a few words about competition?
Yeah, no, first of all, what we have noticed is that there are others with the same thought, and I think that's good. That means that we're not completely, wrong out there. We'll be worried if we were the only ones seeing this, to be honest. However, I can't see that I've found competitors that are thinking of this as a project portfolio scope. Most of them are seeing that they have one mine, either because they're a mine owner and think maybe we can make a pump hydro storage, or that there is an energy company and want to look at one mine. So definitely the thought is out there, and like I mentioned, Vedic also see that this could be a potential scope for them in terms of contractor works in the future. But I cannot see anyone else making this, international development scope out of it.
You mentioned South Africa and that they had a number of many abandoned mines. Do you have any idea of what it looks like globally in terms of abandoned mines?
Oh, no, I don't have the figure of abandoned mines in the world. I mean, we are obviously, when we are looking into which markets we want to be at, abandoned mine, numbers of abandoned mine is obviously one thing, but also to remember there are also a lot of other factors that plays into to be attractive market for us.
But there's plenty of holes in the ground that
there's plenty of holes in the ground. Yeah, definitely. Whoops.
Right. Well, best of luck. Thank you very much.
Thank you. Thank you.
And this concludes today's event. Thank you very much for joining us here at Spegelsalen Grand Hotel at the Naventus Renewables Summit. And thank you all of you listening to us, following us online. You know, Naventus is always present to be able to give you advice in these topics. And we will be back with another summit, and that will be in May 10th. And that's going to be focusing on healthcare. So healthcare summit here at Grand Hotel on May 10th. So see you then. And take care and keep investing in renewables.